My name is Richard Ferrer, and I can say I am cloud hired.
That yes, come and join and get cloud hired. I'm cloud hired.
I'm cloud hired.
I'm cloud hired.
Hey, Go Cloud Architect family. I'm cloud hired.
So I'm cloud hired, guys.
So I'll just say I'm cloud hired.
I'm cloud hired.
I'm cloud hired thanks to Go Cloud Architects.
It worked for me, and now I'm cloud hired. Because of Google Architect program, I am cloud hired. See!
I am cloud hired. Thank you, Mike and the Glowcloud team.
Welcome back, everyone. Leo and I are back for day 2 of our completely free Google Professional Cloud Architect Bootcamp. This is a 2-week bootcamp to prepare you for the Google Professional Cloud Architect certification and exam, obviously. Today, we are going to basically talk about some identity and access management components. We're going to start to get into that today. And I think it'll hopefully be some fun for everybody. But welcome back. Today is day 2. I want to remind everyone that if you were not here on day 1 of this free training, don't worry. You can go back and see day 1 of our Google Professional Cloud Architect anytime you want. Today can stand alone from yesterday. You can watch today's and go back to tomorrow's, anything that you want to do. So please make sure that you go back and watch the original day if you haven't seen it. Someone from my team drop a link to that. Now, we also have a free study guide that if you sign up for, it typically will take about 15 minutes for you to get. And, so fill in the email and then you should receive it in about 15 minutes. So please do so. There's about a 550-page study guide that goes along with this book. This bootcamp should easily prepare you to pass the Google Professional Cloud Architect exam. I know I passed the exam very simply, easily. It was actually I've been designing clouds for cloud providers for decades and have worked with all the clouds since 1993, the first ISDN cloud and other clouds that I worked with. But, I thought I'd get a cloud computing certification. And the first one I did was the Google Professional Cloud Architect. And we built the curriculum based upon what I did for that and what I've done to help others pass this. So you should be good with this. But I still recommend always read the official book. This is the official book recommended by Google. So I do recommend the study guide as well as the video that we have here. And also the other, as well as the study guide we created. And it might be worth doing a practice test because maybe you're not sure the way Google likes to ask their questions, and a good practice test could get you used to the weird way they ask questions or the weird way anybody asks questions. And that way, when it's the exam, you don't have to focus so much on interpreting the questions because you already know how they're structured. You just have to answer it, and it makes it a little easier. So that's something that you can think of too. So that would be my suggestion on it. But anyway, we're going to have some fun. Leo, did you want to say anything before we begin?
Thank you, Mike. Yes, welcome everyone. And please share this with your friends, your colleagues. This is free without any cost. And everyone can only learn and get better from that. Thank you, Mike.
Yeah, so it's great. And everything we're providing here is free. Again, this is an inexpensive book. If you want to get it, I don't get paid anything for buying this, not buying this. I'm just saying that I like the book and I used it when I took the exam about 4 years ago. So it's all up to you. So the way we're going to run this is we're going to basically have a discussion for 20 to 30 minutes. Then we'll answer questions. We have two easy mini labs today on IAM that were, of course, created by Leo. We'll have some more when we get into the networking and things tomorrow. They're going to get a lot more fun and they're going to get a lot more geeky. But today, we have to address some real concepts here. We'll have some intro labs and we'll get geekier with the labs tomorrow. But so, keep that in the back of your mind. The question is, how much is a buck? Our study guide's free. The one that we created, this entire course is free. Everything we've given you here is free, and the training program is free. That was just an unrelated book that I happened to like when I took the exam, when I mentioned the Cybex one. But I like to read books. So let us know where you're from in the chat box while we wait for a few more people to join us. I like knowing where everybody. I see Angela's in Southern California. I just got back from Beverly Hills a few weeks ago. I thought it was really cool to see all these self-driving cars driving around the road. I was impressed with how well they were actually driving in all practicality. The Waymo cars, I think they were called. But where else are you from? I know Leo's in Brazil. That one I know. And I know I'm in South Florida today. And my wife is in Philadelphia. And I really wish she was in Florida. And one last thing that I'll mention is that on Thursday, we're going to have a webinar, and we're going to talk about what it takes to become a cloud architect or an enterprise architect or a security architect or an AI architect, any kind of architect you want. We run a webinar every Thursday where we'll talk about what we actually do in these roles and the skills that you need in these roles. And the skills of the roles are very different than the certification. So I want you to know what those skills are. I also want you to know how to get past the HR people when you don't have a perfect resume so you don't get auto-rejected. We'll also talk about that. We'll talk about what hiring managers want. So if you don't have a perfect resume, you can be the other stuff they want, and that'll go far to help you get your first tech job. And it's completely free. So join us. It'll be live on Zoom, and I look forward to meeting you. Okay, San Francisco Bay. Yeah, that's right. Mark's out there. Little Rock, Arkansas. I think I've traveled the entire world and not made it there. So I have to do that at some point. Darnell in Chicago. There was an Equinox that I used to go to in Chicago that I really thought was a really great gym. Spent some fair time there too. All right, so we're going to get into the content. Everybody will start the content now. Give me a hashtag Google Professional Cloud Architect, because this is a Google Professional Cloud Architect Bootcamp to prepare you for the Google Professional Cloud Architect PCA exam, whatever you want to call it. And then, Chris, let's start the content.
Now we're going to be starting our discussion on identity and access management. And I'll begin with a summary of identity access management, and then we'll get much deeper into some of the Google offerings and the solutions you can do with IAM on the Google Cloud. Okay, so in this diagram, I've given you a picture of authentication, authorization, and accounting. And I'll explain it to you, and then we're going to work through an example together. So authentication is determining if you are who you claim to be. So if I log in as Mike Gibbs, I should be able to prove that I am Mike Gibbs, so I get access to Mike Gibbs things. And someone else should not be able to be Mike Gibbs. So authentication is determining who you are or who you claim to be. And that could be a person or a device. Authorization is determining what you're allowed to do or what you're allowed to have access to. And then accounting is keeping track of what you've actually done. So let's work through an example. In this case, we'll use the example of Cindy. Now, Cindy is my cat. I tend to love this cat. Now, there's a lot of cats in my community that walk around that look a whole lot like Cindy. She's a standard tabby cat. But in this particular case, Cindy went outside for about an hour. She now wants to come home. So Cindy actually scratches on the door, makes a few sounds. And all of a sudden, I look at Cindy and I say, oh, that's my cat, Cindy. And I open the door for the cat. So the authentication is that this cat is Cindy and not someone else's cat. So now Cindy's been authenticated and I know who she is. And now Cindy wants to do a few things. First, Cindy wants to go to the fancy tuna store on her computer. So she goes to the fancy tuna store and the request is authorized, meaning she wants to go to the tuna store. The identity systems in our house say, yes, Cindy, you're allowed to go shop at the tuna store. So she goes to the tuna store. Now, Cindy does whatever she wants in the tuna store. Now she wants to do something else. She now wants my car keys because she wants to go drive to the mall because there's a mall and a special fish market that's 100 miles away and she wants to drive there. But I don't want my cat driving the car. So I've sent up an authorization policy that Cindy's not allowed to drive my car. So now Cindy tries to drive my car and she gets told no. So that's the authorization piece. She was authorized or allowed to get to the fancy tuna store, but she was denied access to my cart keys. And then the accounting piece of this is I actually look at my credit card statement and I find out that my cat spent $200 on tuna. And I find exactly every can of tuna and the types of tuna she bought at the fancy tuna store. So authentication, who are you? Authorization, what are you allowed to do? And then accounting is, what have you done? Okay, so now let's get back into the cloud identity content, but I wanted to do a level set with regards to what is identity and access management, and it's all about determining who you are, what you're allowed to do, and keeping track of it. So initially, when you sign up, you're going to set up your Google identity and your admin account, and that's where you're going to initially navigate to the Google Cloud Console. You'll begin the process of setting up your cloud identity on the cloud platform. You'll sign up for an admin account, and there'll be prompts to sign for administrator accounts. Now, obviously, there'll be some click-through agreements that you have to click through and read. When you click through these agreements, that is a legally enforceable online contract that you actually sign. So please read it. And a lot of signups do this because they have to make sure that you will abide by the rules, etc., what you're responsible for, what they're responsible for, and they typically do it as a click-through agreement. So you have to read them at some point, or the attorneys obviously should read them for you. Now, most of these agreements are necessary to sign before you move on. So please understand, these are contracts that you're signing. So there's a legal implication of it. So make sure you understand the implications of this when you sign up. And make sure that your company policy is going to align with the types of things you see when you read through those click-through accounts. So we'll begin with compliance scenarios in the exam. I want to let you know that there will be scenario-based questions about common IAM things on your exam. There'll be questions on GDPR and very common things and privacy situations that you'll find on the exam. And instead of just asking you an ABCD question, there'll be a scenario and you'll have to read the scenario and you have to think through what might be the right solution. So keep that in the back of your mind. At the end, we'll talk about the various case studies that you'll see on this exam, but we want to teach you the Google Cloud before we get into these types of case studies. So in certain legal environments, like GDPR, you have to make sure that if there's a big kind of a service outage, for example, you don't lose messages and you don't lose data. So typically speaking, in order to deal with that, you'll typically need some kind of a queuing system or a messaging system. And I can whiteboard it out for you to make it a little easy. But sometimes as it pertains to compliance, you may have to do this. So let's talk about what I mean by a queuing system or a messaging system. Let's say you have a server here, and this server needs to receive some information. And let's say you've got the information coming in here. And the information flow is it's going to be leaving from the information source, and then it has to get to the information server. So what if, for example, this server were down? Well, then you would lose these messages. And in certain cases, from a compliance perspective, you can't. So what you would have to do in a situation like this, and you may see a question like this on the exam, is you may need to use some form of message queue. And in this message queue, what you can ultimately do is if for some reason the server is down, the messages will be placed in the queue and they will wait in the queue for the server to be back up. And then when the server is back up, it will send the messages to the server. You know, they discuss this and when you start thinking about certification. So I just want you to understand that under certain environments, we may not be able to lose messages. GDPR has some regulations that way. So because of that, because of the data protection, the data privacy, and some data residency requirements, we may have to do message queues. We also have to understand that there will be legal and compliance rules, and we may need to use IAM things to help keep this to stay compliant. For example, European citizens' data can't leave Europe or the European Union to stay GDPR compliant. Now, what does this mean in a cloud provider where they may replicate your data all over the world? It means you're going to have to do things about this and prepare for these things whenever you deal with cloud computing. If you want to know much more about that, we have a completely free cloud security certified professional CCSP course that is actually sitting on this YouTube channel, which will talk much more about the legal and regulatory challenges in cloud computing with regards to the data. But we just touch on it in this program. So when it comes to messaging systems for publishing and subscriber or queuing systems, in order to make this happen, there are opportunities that we can use. Google has their own messaging system. Apache Kafka is typically one widely used, and the reason it's used is it works in all clouds. So you can think of Apache Kafka, for example, as an open source stream processing platform. It gives you a lot of control of your architecture compared to a managed service, and it allows you to ensure that your data stays where you want it to be when it comes to messaging systems. So Kafka is often something that's typically used. You can also use PubSub, which by Google, which also does similar features and functionalities, and now it supports regional data control. So, but Kafka's inherent control and flexibility might still be preferred when you've got strict compliance scenarios and you've got to deal with multiple cloud providers. So, on the exam, just prepare for to understand service agreements, because they will talk about it and why you have to read the service agreement and what the service agreement is and the implications of it, meaning you signed a legal contract. In general, in many cases, when we're dealing with regulatory environments, we may need control and a lot of flexibility of what we do. So that's what we want to touch about compliance scenarios for the exam. Now we're going to get into much more of identity and access management. It's just one thing to note and think about when we talk about IAM and compliance. And IAM is all about compliance, keeping track of what people have done, all about compliance. So there's so much here. Not letting people do things outside of their scope, all about compliance. Not letting people access private information, all about compliance. So now let's get into the fun IAM stuff. So Google has an IAM service called Cloud Identity, and it's identity as a service, meaning it's a managed identity platform for you to use instead of managing your whole thing like an Active Directory environment. And the point here is it's going to provide a unified platform for identity, access, and application endpoint management. And it's going to be very easy to use. It's going to be very set up, and it's going to allow various users on the Google Cloud to consume and connect to various resources. Pretty easy. There's a couple of accounts that you typically talk about. When you sign up for the Google Cloud, you'll immediately create an administrator account. Now, this is an account with a lot of rights. The administrator account has access and ownership to the entire cloud identity platform. And when you set this up in this administrator account, you're basically setting up a billing account alongside the administrator account, because that's the person that owns the account. So I kind of hope that helps understand when you set this up what that administrator account is. You may hear it called the root account in other cloud environments and other clouds, same kind of concept. Now, we may set up billing accounts. For large organizations, we may have to set up multiple billing accounts. So I want you to think about an international conglomerate that may have 10 different divisions. They may actually want 10 different accounts. So lots of subsidiaries. It may not make sense for a single administrator to manage the entire bill for 10 different departments that they may not even know what those 10 different departments are doing operationally day in and day out. So that gives you the opportunity to do billing accounts and create multiple billing accounts, which is fantastic. You can have the cloud billing account, which is going to pay for the Google Cloud projects and the Google and anything you're dealing with. And it's like and it can be linked to your cloud billing account, and that can be linked to one or more projects. So initially, when you set up the cloud identity and administrator account, it's going to do a few things. One is you basically have to add your domain and verify your domain. So there'll be a setup phase and you'll add your domain. And at some point, you're going to have to verify your domain name. So if your domain name is cindythecat.com, first you have to add that, and then they're going to have to verify that you actually are the owner of cindythecat.com. Typically speaking, there'll be a .txt record, and that's typically generated in your DNS records for verification. And there'll be some form of manual verification that you can do if things go wrong, where you'll have to manually add a TXT file to your DNS setup. But setting up the domain so they know who you are realistically, and they associate the domain with your account. Now, once you have your domain added, you're going to have to add your users. So you'll add various users. They're called cloud identity users. Now, for a large organization, they may have a lot of information, especially with enterprises that are dealing with large environments. And they might be using things like new organizations as well. The key here is when we set things up, we want to figure out how to set them up for scalability. A small business, it's easy. It's straightforward. A single user, a couple of users, there's nothing really to think about. But when you're dealing with a large enterprise, things change. It takes careful planning to make sure you've got a very scalable structure or a scalable architecture that when your users build, it's going to keep growing. Now, when you have one big company over here and they have multiple little billing accounts over the company too, now you're going to have a lot of careful planning that needs to go on as well, and you might need to coordinate these accounts to get a discount for the primary account. So there's work to be done. There's management overhead, and thankfully there's a lot of work for us cloud architects, because we end up doing a whole lot of these then looks, evaluations, meetings with vendors, meetings with stakeholders, that kind of thing. So thankfully that's what we tend to do. So think about that from the perspective of the scalability. Think about the billing management when you set this up. Maybe we want to align the billing records with the organizational structure. And that way it makes sense and people can understand structure-wise the people that need to know what's going on with the cloud expenses, and they can compare their cloud expenses to what they previously paid. They can compare their cloud expenses and the performance they're getting to what they previously had. Since any architecture we have in a perfect world, we're going to get better. So we have to understand that security principles in the cloud are a lot different. We lose a lot of the security parameters in the cloud that we typically had. Typically, we had a back-end environment and in our data center that was completely protected from the internet, and then we had a demilitarized zone outside of our firewalls for things that needed to be used. So there is that. Traditionally, we may have also had a tiered environment and monolithic applications, which we still will on the cloud and off of the cloud, but they're slightly different than the microservice base. Actually, they're a lot different in the way they actually work. So on the cloud, we have to think about what we're going to be using and what we're going to be securing. It's a lot different to secure a single server. That's easy compared to distributed things all over the world, all across multiple clouds. And because we're going across clouds and across boundaries, understand identity and access management becomes so much more critical. So let me show you why it's so much more critical and why it's so hard and why IAM becomes so important. So if we look at this environment, a traditional environment, here's our data center. And in front of the data center is our firewall. Outside of the firewall, we have the internet. And I want you to see how easy this is to protect. Nothing is getting in from the outside into this building, into the data center where the users are, where the systems are. For the most part, if the firewalls are architected well, if you've got a web server or it sits out here outside the demilitarized zone. So web server. And if we deal with this, what does the web server need to get? Typically speaking, TCP port 443 at this point. So all that's necessary is you open a hole in the firewall to a specific subnet for the web server to be. And all that's outside the environment. Now, what happens in an environment, or what we had was we had a very simple architecture, which was like a 3-tier web architecture. So you might have a web server over here. You might have an application server behind it. And you might have a database behind it. And this is pretty typical. But the thing is, the traffic was coming in a single direction. If we had a web server, only port 443 traffic had to hit the server. And we could firewall that off. And then between the web server and the app server, we only had to allow the traffic, typically speaking, we were very particular on the traffic that we even allowed. And then even the traffic coming to the database was only destined for the database server. So this was easy to protect. Now, I want you to think of an environment where you've got things that are talking to everything all over the place. So this could be a service. And this could be another service. And this could be another service. And this could be another service, and these services could be hosted on 2 or 3 different clouds. So now you've got multiple vectors of attack. Things can be coming this way, they could be coming this way, they could be coming this way, they could be coming the other direction. So we lose a lot of this good network security. So the only thing we're going to be able to do, will be more that we can do, especially if we microsegment our environments into multiple VPCs and how we route between them. But all in all, without getting into some fairly complicated networking, we can make sure every request to the server, I'm trying to do this. Are you allowed? No. Okay. I want access to this. Am I allowed? Yes. I want access to this. You allowed? No. So by checking every verification is one of the best things we can do now. That's why there's such a heavy emphasis on IAM. So I showed you the traditional model, and I showed you how, it's easier to defend. And I also showed you how on like a 3-tier website compared to a microservices environment, in many cases, it's still easier to defend because our boundaries, our perimeters, and where the traffic is going and the directions they're going are fairly easy. As it gets further distributed and further apart, network security and other things are still valuable, but they become less effective, and IAM becomes so much more effective. So what are we talking about here? One of the things we need in security is the principle of least privilege. And what does that mean? It means don't give people access to more things that they need to do their jobs than they need to do. So if I need access to this system as part of my job, I will be authorized and given access to it. If I don't need access to this system for my job, I won't have access to this. So by doing this, it limits the damage because now the people that can access the highly sensitive systems are only a small number. And that way we can protect information. Now let's talk about another thing we need to do in security. It's going to be the separation of duties. And this is a great security concept. And it makes sure that no one person can do everything, and therefore they can't hurt the environment. And you'll see this all over the environment. 2 people needed for certain things. Let me give you an example outside of security, as I think it'll make it a lot easier. So let's say you went to your safety, you wanted to go to the bank, and you had a safety deposit box out of the bank. Yes, I don't typically type very well when I type on live, but let's say there was a safety deposit box. But in order to get to the certain safety deposit box, you needed your key, and someone else held the second key. By doing it this way, it would take your key, and who knows, maybe your wife's key, in order to be able to access the account. Now that increases security dramatically. But we can also talk about separation of duties. So let's say we have a person with an important job. And they have a lot of access to this information in that job. Enough information that if left alone and they were malicious, they could cause serious harm to the company because they'd have access to too many systems. But what if we could take these important jobs and share it between 2 people? Now, this does a lot of different things. It limits the harm that the first person or the second person can do. And if the first person and second person don't have enough information or have incomplete information because they only know how to do their job, there could be no harm to us. We may also implement things like job rotations. And here's why. If we have person A, and they have a lot of power, this person by themselves could commit fraud and do certain things. But imagine if we have person A and person B. And every 12 months, they switch jobs. So now if person A does something bad 12 months later, person B will catch it. And if person B does something bad 12 months later, person A will catch it. And when you see that, people are going to be less likely to commit fraud or cause harm to the company when they know they're going to be caught. Principle of least privilege: don't give people access to more than they need to know. Separation of duties. Yes, don't give one person the ability to do it all if you don't have to. Separate it by a large number of people. Minimize the threat surface. So whatever you're going to be dealing with, minimize the risk to it. So if you're dealing with microservices, which are going to be harder to secure than specific monoliths, especially when you've got good perimeters, make sure you've got some good identity and authorization, and make sure you authorize every single request. So if you try to do one thing, you're not allowed, or yes, welcome, those kind of things, and that's what we need to worry about. So when we design any architecture, we need to always think of the potential attack points and the ways that a person could come in, manipulating people. It could be one way, coming in on the network could be another way. And there's all kinds of threats that come out. So we constantly need to be doing threat modeling. We need to be thinking of how attackers can get in and get various threat information feeds to tell us about new and emerging threats so we know how to protect ourselves against them. We always want to find a way to reduce the impact should something happen, reduce the blast radius. And there's lots of ways we can do things like that. We'll talk about separating our environment, but the key is we want to make sure that if something happens, it doesn't necessarily have to cause a big problem. I'll give you an example. Let's say we had 2 VPCs, or 2 virtual private data centers, as I like to call them. If we put everything in a single VPC, let's say we have HR and finance in here, if anything happened, we could potentially lose HR and finance systems. But what we could do is we could take one VPC, and then we could then we could have another VPC, and we could put HR systems in this VPC and finance systems in the other VPC. And we can make sure these two systems can't even talk to each other if we want. And we can still use IAM, but we have a lot of things we can do. Whenever you start thinking with security architectures, you're always going to be looking how that attacker would come in and how you can mitigate or reduce the impact of an attack if and when it occurs. One of the ways you can do, which you can help, is implementing very granular IAM policies. So you know exactly who's going to be using the system. So when we talk about IAM, we're really getting into who can use what. So let's talk about the authentication piece. Who are you, or who you claim to be? There's a lot of ways we've been doing those. If you've ever walked into a building and had to show them your ID, and a person checked your ID or scanned your ID, that's a form of authentication. They're really determining who you are. Now, we can use a lot of forms of authentication. So we can use something you know, which I don't recommend using passwords or PIN numbers, but something you know is something that you know. And we've all used passwords or PINs. Then there can be something you have as a means to identify you. I've got a specific token card with me. And if you go to a cash machine, well, actually, you have an ATM card. We'll talk about other forms of authentication in a second. And we can determine who you are based upon who you are. Your fingerprint scan, your iris scan, the sound of your voice, which sounds terrifying to me in the world of AI replicated voices. But we can do things of something you are. So when it comes to authentication piece or identifying someone, we've got a lot of options that we can actually use. Now, the more forms of authentication we use, the better it gets. They don't let you just stick your ATM card into a cash machine and get money out. You got to put your ATM card in the machine, and then you have to enter a PIN code. And that PIN code where you're typing on the thing with the PIN code is now two-factor authentication because it's something you have and something you know. So there'll be lots of multi-factor authentications we can use. We can use tokens, text messages, lots of means to do it. We could use an iris scan and a password. So lots of things we can do. Passphrases, what have you. Keep that in the back of your mind. So What's really going on is we're having a server that's going to determine what you're allowed to do, and every time you want to deal with it, the client will go to the IAM server and say, yes, you're allowed to it. So I hope that kind of makes sense. Now, the next component we're talking about, again, I'm going to dive deeper, is the authorization piece. And Google would consider that to be a set of privileges that you have that grants the user access to a specific resource. So being denied access to the secret financial files is an example of authorization. Now, the CFO can get access to those files because the chief financial officer needs access to those files to do their job. And that's really what access management is about. Access management is about giving access to those who need it and keeping access away from those who don't, which is a great way to enhance your security and what's allowed to be done on your systems. Because if you can't access the system, you typically can't take its data, or you can't harm the system either. Now, I mentioned accounting is keeping track of what someone has done. And I gave you the example of tracking my credit card receipt for all the things my cat Cindy buys when she takes my credit card. But she's a good cat. She's a very smart cat. So the accounting piece is that logging piece. So Google is going to give you some of these logs. And you'll get cloud audit logs, which is going to be Google's platform level logs that will track access to resources. And you're also going to get application logs. And this is going to be audit trails of the applications themselves and the applications logs. So you get your logs from the cloud, and you'll get your logs from your application. And truthfully, you're probably going to be getting logs from your firewalls, IDS, IPS systems, and other things, which will ultimately use what's called the SIEM system to aggregate these logs and then to be able to correlate events if and when they happen. But that's way beyond this course, although I'll probably touch on it later if there's more security components. So why are we doing all this logging thing? We're trying to get to the point of something called non-repudiation, which is if Billy Bob accessed the systems and broke something, and Billy Bob, were you here? No, I didn't. He wasn't here. I didn't touch the system. Well, Billy Bob, I got access to your lab. Oh, so that's why we're doing the logging. And it's an example of a person saying, I didn't break into the building, but having the security cameras that said, yes, you did. And that's what we're dealing with this concept of non-repudiation. So think about this. Let's talk about an IAM scenario in action. So let's say you want to enter a secure area of a building. You enter your badge, which is hard to get, and the badge determines which rooms you're allowed to, and then you answer a question or enter a password. Now, the authorization piece is you've got access, you've been allowed to the room, or no, you're not allowed in. And then the accounting piece is maybe there's a video camera that takes a photo of everybody that enters the room at the time they actually enter the room, and they follow the person around, and there's cameras, and then all of a sudden they've logged every activity they did, and they have provided video proof. So this is what we're talking about from that AAA IAM perspective. So let's talk about implementing IAM in large organizations. It gets big, and this can be a big topic. So what happens when we have an organization with global operations? And they're going to have companies in different parts of the world. Employees are going to have different access requirements. There'll be different legal requirements in all these environments. Now we're going to need something pretty deep. We're going to need something that is going to be robust, it's going to be easy to manage, and it's going to be enforceable. And in many cases, this gets us to what's called centralized identity and access management. Now, there's lots of ways you can centralize your IAM. You can distribute it. There's a lot more things that is way beyond the scope of the Google Professional Cloud Architect exam. But you'll hear much more about it in the CCSP and CISM exams, and even CCSK exams and training. And there's free resources for those on side of our YouTube channel. So please enjoy. So keep that in the back of your mind, and understand that defense in depth is still important. And I'll explain what defense in depth is, and we can use it with IAM, and we use it with other structures. So imagine we've got a castle to protect, or an important application, but let's say castle. I mean, I want you to think of where IAM actually fits in. And in the cloud, it may be our only choice, but let's talk about environments where we needed something more. So let's say this is our castle. And I want to show the difference of where IAM fits in. So if we actually had a castle, if we really wanted to protect this castle, I'd make sure that maybe there was a wall around the entire castle. And I'd make it a big, thick wall. So let's talk about this wall. This wall might be 100 feet high. This wall is going to be very, very secure. And I'll tell you what we would do with this wall. So we'd have this wall over here, and that we would have a hard, strong gate that can open and close. And of course, and this way we could let people in when we need to, but not when they didn't want to. Now, imagine we're protecting the king, so we'd probably put somebody on the roof that could protect these things. So we'd put some warriors on the roof. And by having warriors on the roof, if anybody tried to scale the roof or there was a problem, the warriors on the roof could remove the threat prior to them even to getting there. Now, I wouldn't just have a bridge that comes into the castle that is automatically there. I would probably have like a lake or a moat. I'd have this thing surrounded by water. And the reason I would have this thing surrounded by water is if it's surrounded by water in all different directions, it's not, oops, bear with me a second. So if this thing is surrounded by water, and there's water absolutely everywhere, bear with me, I'm going to draw the water. For now, you would have to open the gate, and if you didn't open the gate and somebody tried the walls and the warriors couldn't stop them from climbing the walls, now I'd have this water thing to contend with. And if it was me, I'd fill the water with hungry sharks or hungry alligators. So in other words, the person would have to either break through the gate without getting taken out by the warriors that are sitting on the roof, climb this 200-foot wall. Then if they manage to get past through all of this, climb through the water, which is filled with sharks and alligators and something scary. And then I'd actually have some other guards over here. And these would be scary guards. And I'd have these guards here. And the guards would protect anything that managed to get out of the water. Now, of course, if the castle people wanted to leave, all they would have to do is open the bridge and they'd be outside. So it would take a lot to break into this. But now let's see where identity and access management actually would come in. So here, the person would have to breach the high wall, not get harmed by the warriors, then manage to get past my shark and alligator infested water. And if they finally manage that, they'd have heavily dangerous guards here. And then when they'd finally get to the door, they'd say, "Hi, I'm Cindy the cat. Am I allowed in?" And the IAM would say, "Yes, you're Cindy the cat. You're allowed in." Or somebody breached the system, and now they try to get in, and they say, "What's your username and password?" And they don't have it. So this is where the IAM piece typically fits in. It was always the last line of defense, because at this point, IAM is you've gotten there. Am I allowed in or not? And what can I do? All of this stuff was keeping you get from the IAM place in the first place. But in cloud computing, it's much harder to protect this, because look why this is so easy to protect. There's only one ingress point, and that's the gate, and only one egress point, and that's the gate. In the cloud, we may have people coming at us at all angles when we have highly distributed applications. So let's think of some key considerations for our cloud security environment. We want to implement a consistent and a secure identity and access management solution across our global operations. We're going to have to do other security measures too, but at least for identity, because this is the identity and access management segment, understand we're going to need heavy duty IAM to make it work in the cloud environment. We need to be able to audit systems from an accountability perspective, and in many cases, a legal and compliance perspective as well. We strongly suggest that nobody use just a username and password. Google doesn't tend to recommend it at all. Use some flavor of multi-factor authentication when possible, and things that are more dynamic like tokens whenever possible to protect against unauthorized access. Especially this way, if credentials get compromised, they're temporary credentials. If they're tokens, then they won't. The amount of harm somebody can cause is typically much less if a credential expires in 30 minutes than if they had a password for, say, 6 months. So those are the core concepts we've talked about: the principle of least privilege, the separation of duties, and now we're going to talk about some more about IAM. All right, IAM, to me, it's kind of fun stuff, but then again, I've always been in security in some way, shape, or form, security architecture, network security architecture. So I wanted to see if anybody has any questions, and if so, we'll take a few questions here. Also wanted to remind everyone that on Thursday, every Thursday we do this, we'll have a How to Become an Architect webinar where we'll go over what we do in the architect role, the skills you need, what hiring managers are looking for, how to bypass HR so you don't get auto-rejected, all those kinds of things. And it's completely free. It'll be on Zoom. You can come, you can ask any questions you want, and we'll do anything we can to help you and answer your questions live and free on Zoom. So I wanted to remind everybody about that. And we also, if you just joined us, there's my team put up a playlist that starts at day 1, so you can go back and catch the first day, which was yesterday. And we also have a free ebook that you can download. It's about 550 pages to help you pass this exam that's going to correlate along with this course. So if there's any questions, great. If not, I hope you guys are having as much fun as I am with this kind of content. So I love talking about anything related to security, all kinds of security. So are you guys awake? Am I keeping everybody awake? I don't want anybody falling asleep on castle architecture and documentation like that. So if you're awake, let me know you're awake. Give me a hashtag Google Professional Cloud Architect. If you're enjoying the content, maybe give the video a like, maybe subscribe to our channel and hit the bell to be notified of new videos to help you in your architecture career, whether it's a cloud architect career, security architect career, AI architect career, enterprise architect, or network. So give me a hashtag Google Professional Cloud Architect, and I guess we'll get back to the content. So nice to hear that, Tish. And if any questions do come up, please feel free to bring them in the next break. We want to do anything we can for you with this Google Professional Cloud Architect training. And thanks, I think it's fun. I love this kind of tech stuff. All right, I see a lot of people are awake. They're learning. They're having fun. Now I feel great. Chris, let's get back to the contact. And if questions pop up, we're excited to answer them next time. Continuing our discussion on identity and access management, I'd like to begin our discussion on role-based access control. And I'm going to map it out for you with a graphic, but I want to let you know why we're doing role-based control and what it actually is. So imagine you have an organization with 100,000 people, and somebody manually had to enter all 100,000 users and give each user the exact specific rights they needed to do their job. Now imagine over the course of a year, people move around, they change jobs, they need temporary access to something and vice versa. So a lot of complexity is going on. So imagine first having to manually enter 100,000 users and get their privileges right without making human error along the way, and then deal with the changes of permissions. Well, I hope that sounds near impossible. So what if the moment you hired someone and HR hired someone, they were given a job? You're a sales engineer. And as soon as HR entered that person that was hired as a sales engineer, what if it automatically kicked off a system that basically said the sales engineer needs access to these certain things. So we have a group of sales engineers and we'll add the user to it. All done automatically by the HR systems. So let me whiteboard this out because it might be hard to visualize without it, but this is what we're actually talking about. So instead of having different rights for every user, I can, from a management perspective, create a group of users. And these group users could be systems administrators. These users could potentially be sales reps. Users could be sales engineers. Users could be managers. Doesn't really matter. So what happens in the most scalable way to do this is, let's say Cindy gets hired. My cat's very smart. She's been desiring to get a job. So let's say she gets hired. Now, Cindy, I can tell you, is an excellent manager. And the reason I can tell you this is I do whatever she tells me. She just looks at me. She makes a sound that I do whatever we want. So we hire Cindy as a manager. My cat, Cindy. Now, Cindy is hired as a manager. So as soon as she's hired, she needs access to certain management systems. So HR adds Cindy to the manager group. And then the managers need access to these 10 systems. So it's a compensation system they need access to. They need access to a vacation system to approve PTO. They need a performance rating system, so they have access to this. So as soon as Cindy's hired, immediately she becomes a manager. The manager is Cindy's role or Cindy's job. And what's happened is the permissions are added to the manager. And then Cindy's added to the manager group by HR provisioning the system. And now Cindy can access all the things she needs for her job. Now, Cindy desires, because she's a mischievous little cat, to have access to the systems administrator's information. And when Cindy moseys herself over there, she gets denied. So that's what we're talking about. We're talking about creating a job function, giving specific privileges to that job function, and then adding the user, like adding the user Cindy, to that job function. That's role-based access control. And I hope you can understand how that would relieve the human error mistakes trying to provision these systems, make it easy to change things. Someone changes from manager to director. Now they need access to new systems, and maybe some of their old accesses are actually pulled. So that's how we're working with role-based access control on all cloud providers, and truthfully in all data centers for the last 30 plus years. So the separation of duties we talked about, and we're going to talk about it a little more. The key is to make sure one person can't do too much. You may notice that militaries have weapon systems. In order to launch some of them, it takes 2 people to do it. And they typically have to be 2 people of very high rank to do so. Well, it's the same thing that we're trying to talk about here. We want to reduce the number of security incidents, and we want to reduce the impact of a security incident. So we have to think about all these things. Now, when we're dealing with a cloud architect or a cloud security architect, we have to understand a lot of things. We have to make sure the systems are secure, but we also have to make sure the systems are still usable, and the systems function properly, and the systems perform properly, and most importantly, that the systems actually do something for the business. So we want to be thinking about these kinds of things, but at least think of using multiple security controls. Defense in depth and zero trust kind of merge them together, and then you get to your goal. And zero trust, which is heavily used in cloud computing, is more about micro-segmenting your environment, encrypting absolutely everything, and then for every single request of a system, determine if the user has access. And if it does, give access. And if it doesn't, deny the request. So now let's think about something else. I want you to think about the dynamic nature of cloud computing. Spin up 10,000 virtual machines, close down 10,000 virtual machines. Take an application that you have, roll out a brand new one quickly and easily and dynamically. You're on one cloud, and all of a sudden something happens to your main cloud, but your systems and data is back up to another cloud, as well as images of your virtual machine. Launch an infrastructure as code script and bring it up immediately. And, cloud computing may cost more, but the ability to create a script and immediately deploy an infrastructure in seconds or minutes versus weeks and months or years is incredibly powerful. So we want to understand that we have infrastructure as code tools. So when we do this, we want to provision the virtual machines, the technology the right way. And we need to make sure that any orchestration engines we have are patched and secure and we're using it properly. And we want to make sure that the operating systems of everything we have are patched and booted, or whatever, when they're booted the first time, for example. And we need to make sure that we limit everything. So infrastructure as code does give you the ability to do a lot. And why is that? You can limit the users to producing things that only work, limited to a certain number of virtual machines, for example, with a specific operating system. As soon as the infrastructure come up, it can be set up to have mandatory controls that certain things have to be done. And infrastructure as code is not only a great way to improve efficiency, but it's a way to input some governance in your systems. A user wants to try something, install something, but they can't because they're not allowed. And in many cases, this can be a big boom to our security. So thinking about security with regards to some of the administrator privileges that we can give people in some of the roles, let's think about that. We have to be careful that roles like super admin are limited to those who need it. We have to make sure that stuff isn't exposed to the internet that is not supposed to be. And let's be fair, that's the easiest way to get hacked. Keep your systems that are not needed to be reachable from the internet away from it. The internet's full of all kinds of bad actors. And if you ever look at a business's firewalls, you'll see people trying to hack it every couple of seconds, every couple of minutes, depending upon how big the business is. If it's a big enough business, you'll see people trying to do hack attempts every second, every minute. So it's constant. So we need to think about the way we design our systems. We need to think about how people could actually get indirect access as well. For example, there's lots of ways to do remote access and do it very well. One of the mistakes I've seen people make is the use of a bastion host. And I'll show you how this could provide indirect access. So normally when we have a system, we protect it on the internet. But imagine having an internet here. And here you go. You've got the internet. And for some reason, somebody thought the best way to get in would actually be to put a virtual machine here. And with this virtual machine, it has two network cards. One that's attached to the internet, and the second network card is attached to the private centers, private databases, or let's just say the private systems. Now, this is pretty terrifying because people leave this virtual machine here. Here, the Windows remote desktop to it, or the SSH to this virtual machine, and they'll jump in. But see, you have this virtual machine on the terrifying internet. This is scary. Now, if you wanted to, from the internet access to some form of remote access, there's lots of ways people could do it in a more secure environment. For example, they could have their ISP here, and after the internet, what they could do is they could put a network load balancer, for example, if they really wanted to do it, if they were really careful about it. And behind the network load balancer, they could put a couple of virtual firewalls. And these firewalls are very good security hardened devices. And then behind we could use these just as firewalls to segment the system, or we could do remote access to those firewalls. But let's say we wanted to get really careful. We'd use one set of firewalls to protect the system, and then we'd have another set of firewalls. And off of these firewalls, for example, we could create a demilitarized zone. So, and in this demilitarized zone, which is still outside of our environment. Hold on, let me share. Let's draw a private environment to show you how you could get much more careful. And here's where we would put something called the VPN concentrator. Now, the VPN concentrator, which is effectively a firewall on its own, the only thing that would be allowed on this subnet from this firewall is going to be the IPsec port, which is just the IPsec ports, which I'm drawing a blank on right now. So we only have to allow through this firewall. These firewalls, bear with me. These firewalls can inspect the traffic and make sure the traffic is good and look for any patterns of behavior that are going on, like somebody wants to start a DDoS attack, for example. These firewalls check the data, and make sure everything's good. And then the second set of firewalls does this verification check and then only allows IPsec to the VPN concentrator. Now from here, we can bring the VPN concentrator back. But the key here is this VPN concentrator was made by a security company that specializes in this, and they know how to harden the operating system. And we're using firewalls to protect and make sure that the only thing that gets to here is the VPN is IPsec to the VPN concentrator. It's very different than the bastion host, which doesn't have commercial enterprise next generation firewalls protecting it for remote access. So let's start thinking about more security measures. So we want to make sure we limit the rights that we're actually using and making sure we don't have direct or access to the internet or indirect access to the internet. So you need to think like an attacker when you're trying to secure systems or protect things. You have to think, if I was going to attack, how would I do it? And that way you can think about the vulnerabilities or the weaknesses you have in the system and how you would secure it. To be fair, in a real enterprise environment, we hire ethical hackers or people to break into the system so they can tell us how they did it so we can find the weakness of the system, because you can't necessarily be objective with yourself. That's why lawyers don't take themselves as a client, and you need an external perspective. So kind of keep that in the back of your mind. Assume people are trying to attack you at all times, because they are when it comes to cybersecurity, and then think about what it takes to do this. So you have to design systems assuming that a lot of things are going to go wrong. Murphy's Law, whatever can go wrong will go wrong. That needs to be part of your system design. So you need to think about multiple parts of the system failing and still being up and running and secure. And we're going to minimize risk through careful design planning and security practices. Again, this is way above anything in a Google Professional Cloud Architect. This is security architecture that we're dealing with. Keep that in the back of your mind. But this is what's covered in the exam. So the key takeaways is separate duties, make sure two people can't do one thing, implement the principle of least privilege, and for the purposes of this exam, use role-based access control, use infrastructure as code to limit and secure what people can actually do, and design your systems to reduce risk. Look, when it comes down to it, there'll be other types of identity and access management, things that might be smarter than role-based access control. We will have things like attribute-based access control and context-aware identity and access management, and these get much more sophisticated in their protection level. There's videos on our YouTube channel how to do that, but it's not inside of the content of this program or the Google certification. And I want to keep it as somewhat focused to the certification, although we've added a lot of additional context to help you. So now we go back to the Google services, and we have the cloud identity. And the cloud identity is that identity as a service that provides that unified platform for identity and access of our environment. Now, when we deal with these things, we have a concept of an identity provider. And an identity provider is a third party that we typically talk about that provides identity services. So it could be Active Directory. If you ever go into a website and it says log in with Facebook, log in with your Google account, Google is the identity provider, and people are connecting to that or federating to that. So when we connect to identity providers, it does a lot for us. So let me give you an example of why we might use certain things. So let's say we have two cloud providers, which everybody does, at least two. And let's say this is AWS, and let's say cloud provider 2 is going to be Google. Now, we could attempt, and let's say the users are using both systems, we could attempt to manually do our identities in AWS and manually do our identities in Google. That gets really ugly. We can basically deal with an identity provider, and with an identity provider, with an identity provider, what'll happen is when you're on, if you logged into Google and needed, what happens when you go to log into Google, it'll ask the identity provider, does the user have the account, and the identity provider will answer Google with all the information that it needs. And then Google will use the information from the identity provider to determine if you're okay. The same thing would happen here. It's typically called federation. So what you're doing is you're trusting the identity provider and you're using their information. So if your systems on AWS trust the identity provider and your systems on Google also trust the identity provider, Ultimately, what needs to happen is you make the changes here on the identity provider, and those changes are withheld on all your cloud providers, because the identity provider becomes the source of truth, or the master identity provider. Now, in order to connect to various identity providers, you typically need a protocol that will connect to them, a language. Because if I'm speaking Greek and someone else is speaking French, we got a problem. But if we're both speaking Greek, it's good. Now, what's the population and the chances of me speaking Greek to someone? Well, I think there's 10 million people 10 million Greek people in the world, or something like that. 15 million people, 20 million, not that many of us. So chances are it's not going to be very easy for me to find somebody to speak to them in Greek. But what if I spoke to them in English? Pretty good chance someone's going to be able to speak in English. Or what if I spoke Arabic? There's a pretty good chance somebody's going to speak Arabic. And potentially Spanish, there's a pretty good chance somebody's going to speak Spanish. So I can create a few official means or languages to connect to other environments. And we're going to talk about two very common ones, and one's going to be SAML, and the other one is going to be LDAP. So SAML, or Security Assertion Markup Language, is an open standard for exchanging authorization, authentication data to a identity provider. So it's like saying, we're all speaking English. And that's one form of the security assertion markup language. It's commonly used, it's the standard, and it's going to make it easy for systems to talk to each other. We can also use LDAP. Active Directory tends to use LDAP as well. And it's going to be an open standard that enables directory services to talk to each other. So it's a similar language. So let's say that's one's like speaking French, or because for a lot of people speak French. So, okay, we can speak over the French protocol, or we can speak over the English protocol. So SAML is one way to do it. LDAP is another way to do it. Now let's talk about the types of identity we get with regards to the Google Cloud. So let's talk about additions of cloud identity. So if we're dealing with free services in the free tier, we basically have user security management, and we've got upwards of two-step verification. We have some basic mobile device management capabilities. We have the ability to use Google Cloud Directory Sync, which we'll talk about, and we've got some basic audit logs. And we can collect them from the admin console. Now, if we need better, we can move up to the premium tier, and that'll give us advanced mobile data management tools. And we need device management tools. And device management tools enable you to figure out, like, of your 100,000 phones your employees might have. And device management tools may help you say, okay, these user devices need additional security and we're going to push it. Or the user's notebook was stolen, wipe it remotely before anybody accesses the data. So typically speaking, when you're dealing with device management, you're going to need it in the enterprise environment. And that's why it's there for the premium tier. LDAP, secure LDAP, a component of the premium tier, because let's face it, in the reality, nobody's going to be maintaining their IAM systems on the cloud. What they're going to be doing, ultimately dealing with, is they're going to be using some kind of federation or connecting to something else, often Active Directory, which would use LDAP. Now, you will also in the premium tier have the Google Security Center. That's going to be access to some advanced security tools. The reality is you're probably going to end up buying more industrial tools to use across all your clouds, but these are very good tools. You'll be able to export your logs to Google BigQuery, which is a data warehouse. You'll be able to deal with that, and you'll get an SLA of 99.9% uptime guarantee. So on the premium tier, you've got some pretty good standards that you're getting, some pretty good IAM capabilities. So which do you use? Well, you may use the free tier if you're going to use existing third-party tools, because you may not need to pay for it twice. But the premium tier is going to give you much better security. And for organizations that need high levels of security, they're going to need the premium tier with some of the tools they're going to be working with and integrations they might need. So it depends on the organization's needs. When we talk about cloud identity, it does have its own benefits, in that it's a fairly simple single platform to manage identities across your applications and endpoints. It's integrated very seamlessly into Google services, which that makes it easy, and many third-party services. It supports advanced security features like SAML, and secure LDAP, which is obviously important. It tends to scale based upon the tier that you're actually using, and it tends to help an organization meet compliance needs, like audit logs in the Google Security Center, because it's an IAM system, and IAM systems help organizations stay compliant. So let's talk about managing identities. So as cloud architects, we're not going to touch these technologies ever. We're not going to be allowed to in our job. But cloud admins and cloud engineers will be touching the technology all the time. So when it comes to being able to manage users, at some point, we're going to have to create or import users. The engineers would be doing those. And they'll have to understand how to manually create user accounts in the Cloud Identity Directory. They'll also have to know how to import the existing user accounts into Cloud Identity, potentially from other directory providers. So for the cloud engineers that are going to be working on these things, that's where the accounts will be created. For the people that will be managing this, isn't this also often the sysops role that are going to be maintaining these identities over time? Now, at some point, the user's lifecycle will also need to be managed. When a user comes into the company, there'll need to be an onboarding process. There needs to be a procedure for adding new users to the Cloud Identity Directory to make sure they have the necessary rights and permissions. So that needs to actually occur. As users move from one role to another role, we need to manage their prescriptions or their permissions accordingly, because they may not need access. And the worst thing we can do is what is called privilege creep. And privilege creep gets scary, and we have to deal with that from a security perspective. This is privilege creep. I had a person, and this person was a manager. And because they're a manager, they get access to manager systems, right? And for some reason, the manager decided that they wanted to take a sysadmin role for a long period of time. They actually missed their tech days. So now the manager decided to take a systems admin role. Now, the manager needed access to these systems: finance, HR, payroll, bonus systems, expense reports. And the systems admin, by comparison, this person needs network access to the routers, switches, the IAM systems, operating systems. Ugh. Okay, so you're seeing this. So imagine we have this user, and they've had these privileges, and now they take a sysadmin role, and now they get these privileges, but nobody ever took their privileges away. Now the manager, who decided that she didn't like being a sysadmin, and she didn't really love being a manager, decides she's going to do another role. So now this person, the manager who's now the sysadmin, now this manager goes to marketing. Now all of a sudden, this person needs access to market research, advertising systems, budgets and systems. Now, if we're not careful, and we didn't change the person's or take away the person's permissions that they didn't need for the job, at the end of the day, we have a marketing person that now has the ability to delete parts of the network, delete servers, access the finance system, and when they really only need access to do is market research and advertising budgets. That's called privilege creep. So the key here is it's going to be responsible for, we have to be responsible, and the people that are going to be touching these identities need to make sure that as people change jobs, they don't keep their old permissions. Their old permissions get taken away, and they get new permissions that are related to the role. So when we bring the person in, there's a specific set of procedures teaching the new users what to do. As the user changes roles, guess what? Their permissions change along the way. And as the person leaves, we need the proper procedures to collect equipment, offboard people, terminate the person's accounts and permissions in order to make sure we maintain security. Now, when possible, we want to use more than one single form of authentication. So that brings us into two-factor authentication. You may hear Google call it two-step verification. And basically, it's using two forms of authentication to prove you are who you claim to be. So I log in, I enter my username and password, and then it asks me for a token. I give the information from the token from the card that I have, and then it gives me access to the system. So we really want to try and make sure that whenever possible, the people that are configuring the systems will set up and enforce two-step verification for users. Now, we also may get involved in something called single sign-on. And single sign-on is when you log into one system, you'll get access to other systems. And by doing it, you don't have to log in 10 times per day. Now, by doing so, there's things that it can handle, and I'll whiteboard it out for you a second. But we can use cloud identity as the identity providers for the single sign-on, where cloud identity will give us the ability to use other things, or we can use a third-party identity provider. So let's talk about why organizations are doing this. Early in my career, here's what ultimately would happen. You would see someone's desk, and they needed high security into 10 systems. So you'd go to their desk, and here's what you'd see on their monitor. You'd see the monitor you'd see a username and a password, and it would literally be on a sticky note on their desk, and it would be for finance. And because they had 18,000 other systems, they'd have another sticky note on their desk for the routers. And what would happen is the person would have 10 and 20 different sticky notes on their desk. This sticky note is going to be for secure, let's say, firewalls. And because it was so complicated for the person to remember all their systems, what they did is they cheated. And ultimately, they ended up reducing the security because we forced out lots of passwords, and it was a problem. So there was one problem with multiple accounts. The other problem is if it takes 2 minutes to log into this account and 2 minutes to log into this account and 2 minutes to log into this account, and a user has to log into 100 accounts a day, that's 200 minutes, which is nearly 4 hours logging in and out of accounts. So I hope you could see that's kind of icky. So we don't want that. Instead, what we want is something that's called single sign-on. And single sign-on is going to be this. When I first want to sign on to the system, I'm going to sign on to a system. Now, we're going to make sure that this sign-on is going to be a secure a good, strong, I know who you are. So now Cindy the cat, and we've seen Cindy before today. So Cindy signs on to this system. And now Cindy goes to the fancy tuna store because she's allowed without logging in again. Now my cat also likes shrimp, so she goes to the fancy shrimp store. And while she's at it, she really likes turkey. Now, it's only Boar's Head brand turkey, but she decides to go to the fancy turkey store. And the key to remember with this is she's only logging in once in order to get to these systems. She signs on, and then she doesn't have to sign on to any of these systems. And because Cindy doesn't have fingers, she has paws, it's pretty hard for her to sign on the system in the first place. So she likes signing on once, and then she gets her tuna, her shrimp, and her turkey. So that's why we use single sign-on. It makes it easier for our users, and it protects them from doing scary things. So when we think about managing users in cloud identity, we want to think about user account management, and that's going to be that our accounts need to be managed effectively from the time they're created to the time they need to be modified to the time they are deleted from our systems. We can use role-based access control to manage our permissions. at least for the purposes of your exam. Some best practices include to regularly review and update our security policies, use two-factor type authentication and single sign-on. And we want to maintain, from a compliance perspective and an audit perspective, strong and detailed logs of everything that we actually need.
Okay, we are back. We are here to answer any questions. It looked like two fun ones actually popped in while we went through the discussion, and we'll do that. So I see there's a couple of questions, but if you've got some, ask some. The first one I know is going to come in about a bastion host, and we're going to architect that one, and I really want you to see it and why no one ever needed to use this in the first place, or should have. Hi, Mike. So the bastion host is not a best practice. No, never. So what if servers are in private subnets and need troubleshooting? How quickly do you do this, and how do you do it? So let me show you what we've actually done for the last 30 years in almost every environment. In fact, the only time I ever heard a person even talk about a bastion host was during a cloud provider certification. And the people that were talking about it, honestly, never worked in the cloud, didn't know anything about the cloud. So they were making it look like this was the way to do it. So let me show you how normal organizations do it. So let me just bear with me. I'll make sure that I get to the right size here. Oops, bear with me. Okay, so if this is where my campus is, first understand that most people still have some servers and things in their facility, but let's just say this is where my campus is. Now, that's where my employees are. Now, the campus is always going to be connected to the cloud. Otherwise, you won't be able to reach the systems on the cloud. So let's say this is your cloud provider, and these are all your private subnets, which is basically where all your data, all your applications, all your everything is. So what happens is we have to create a wide area network to the cloud provider. And we either take a private line, and we typically use a private line, which is basically a wire that you purchase, an Ethernet cable. There's some subtleties, but you own that wire. You can encrypt over that wire, and then all the work is done from the private systems through a private wire with encryption on it to the private subnets. Now, this could have also been an IPsec tunnel between these two environments. It could be a software-defined WAN, like an SD-optimized WAN. It could be a secure access, secure edge WAN, but realistically speaking. Now, that's what we've always done. Now, let's say we have a remote access user that needs to get onto this campus. So let's talk about how we normally do remote access for management in a high security environment. So let's say here's your internet connection. Right behind your internet connection, you're going to have, typically speaking, more than one firewall. So let's say it's in a cloud provider, or it could be a data center. We'll have a network load balancer, and we'll typically have a layer of firewalls. Now, will typically be a next generation firewall. These are hardened devices, and we're going to be really specific, and we're going to say that no traffic is allowed in here at all, like zero. Nothing will be allowed in here at all, except for whatever we allow. Now, let's say it's a really high security environment. We might use another set of next generation firewalls. And then what we might do behind here is put a load balancer. And this is normal remote access at most companies. And behind the load balancer, we'll have two VPN concentrators, which are basically firewalls. And what we'll have is VPN. So in order to even be able to get here, we're going to set up an environment where they're going to have to go through the internet. Our internet traffic will be protected by next generation firewalls. These firewalls will look at the traffic, make sure it conforms to a policy, what have you. And the only traffic that's allowed in is IPsec. Now, this then goes to another hardened system. That's two more firewalls that are going to verify it. Now, as soon as the request is going to hit this VPN server, the VPN server is then going to say, okay, do I allow or not allow? So then the VPN server is going to go into an IAM system. And if the VPN server allows you into the IAM system, it'll take you back to the campus, which is where, again, you can manage over this environment. But note, in order to go through the internet, you typically have to go through real extreme filtering from a couple of sets of next generation firewall. And these VPN concentrators are security appliances that are built by experts in security to know how to lock an operating system down and make sure it's not hackable. Now let's talk about the exact opposite, which is the most risky thing in the world, which is called the bastion host. So over here we have the internet. This is where all the hackers live. And on the internet, in the middle of nowhere, for no reason whatsoever, we're going to put a Windows or a Linux system here. We're just going to put an exposed host in the internet, and we're going to basically give it a public IP address, a public subnet, or an external IP address. And then on that same host, we're going to put another NIC or another port, which is going to be a private address. And this address will be in the same subnet as all your other stuff. So what any hacker can easily do, and this is going to be nothing to do, is easily just hack into this host, and now they've got a back door. So you'll never see a bastion host in a real environment. This was something that a bunch of people got certified in cloud architecture, didn't understand what they were doing, and started teaching it as a way to connect. And that's why everybody's talking about it, because the people that didn't understand networking, didn't understand security, were teaching people to do this. And that became the way you backdoored into your cloud. But then again, that's the way the hackers backdoored into your cloud too. So most organizations got rid of that. What happened is Azure looked at it and said, these people are doing this. This is crazy. So we'll make a remote access service and call it Secure Bastion. Amazon saw that and went, wait, these people are going to get hacked. This is crazy. So they made their secure remote access. But what I showed you is what we've done for 30 years. You've always been able to do it and never needed this. Kind of hope that helps. When an organization opens a Google account for billing purposes, how do they ensure multiple people have access in case one person in the account leaves the company? Okay, so great question there. So the first thing is we're going to have root accounts, which we're going to lock up, typically speaking, and not share. And then what we'll do is we'll create a shared group or a Google share group, and basically that's going to be an account that's going to be a billing account. And what we can do is we can create a billing account. We can assign various billing roles, like a billing administrator or a billing account viewer. And that way, what we can do is create a trusted set of people that can get involved in billing or purchasing, that kind of thing. Now, we can also link that bill to an organization-wide account, which we'll talk to later when we talk about our account architectures and things like this. And realistically speaking, that'll be a global wide account under centralized building. And that means it'll be managed through Google's Cloud IAM, and it won't be tied to a single person like if you signed up with a Gmail account. So that's typically what we do. But we are going to be talking about this and how to do this in this bootcamp. It'll be more towards the end, but we're definitely going to talk about that more. Darnell, does a cloud architect need to be a certified ethical hacker? Definitely not. Or understand the cyber kill chain or MITRE attack. So, Darnell, we actually have to really talk about what is the goal of the cloud architect. The cloud architect is to help an organization solve its strategic challenges. And that means the cloud architect somehow needs to shape the people, the processes, and technology. So what we really need to do as a cloud architect is understand the client's needs. What's the client's business goals, the client's business pain points, the client's challenges, the client's struggle. We need to understand what our client's competitive landscape is, what the client's business architecture is. How does that business make money? Where are the pain points and the processes that it actually has? From those given pain points and the processes in those given industry channels, what kind of a technology strategy can we create? Now, when it comes to creating a technology strategy, Darnell, I mean, it's going to take 15 to 50 people. The architect's not exactly going to build this thing. So the architect's going to have to create this design, which means speaking to a wide variety of stakeholders, understanding the organization's 50 to 1,000 applications, understand their tens of thousands of locations, understand all of their applications, all of their networking, all of their security. That cloud architect's then going to need to build a team, and so that team can understand it. You can start examining various business challenges and think about which trade-off they have for various architectural options. Then that architect somehow needs to be able to create a statement of work, create a governance structure, sell the architecture to the team, build the business case around it, build a governance structure and those type of things, respond to any RFIs, RFPs, RFQs. And when it's done, it's time to go to the new client. Now, Darnell, if you ask me if a security architect needs, I would say no, they don't need to be an ethical hacker, but they need to know how organizations are hacked and understand what goes into security architecture. Now, the security architect would be things like application security, network security, identity security, physical security, security policies, disaster recovery planning. So it's all going to really depend on exactly which role you want. But nope. Most architects don't know how to break into systems. Most architects probably wouldn't even know how to touch the technologies, especially if they've been an architect for a long time. Architecture is strategy. But Darnell, why don't we talk about this on the How to Become an Architect webinar? And I will tell you, if I'm looking for a security certification for a cloud architect, I generally recommend the CISSP. In fact, when I train architects, the 3 certifications I teach them, one is a cloud professional, one like the Google Professional Cloud Architect or the AWS Solutions Architect Professional, the Azure Solutions Architect Expert. One is a TOGAF, which is an architecture framework to ensure digital transformation. And for security, I usually use the CISSP because that's kind of like this blanket, everything you probably wanted to know a little bit about security. And it also gives you good technology underpinning. So that's why I typically like that. But no, you definitely don't need to be a certified ethical hacker. Okay, well, if there's any other questions, please ask them. To let me know you're awake, alert, and oriented, maybe give me a Google Professional Cloud Architect. If you like cats, let me know you like cats, and I'll make more cat demos. I don't know. I just love cats. Admittedly, I'm a little bit of a cat cuckoo there. The next video we're going to play is short, so if you've got any questions, don't worry. We'll be back very shortly.
Continuing our discussion on IAM, we're going to talk about creating the identities in Cloud Identity and Access Management. And the sysadmins that are going to create our identities are really going to have 3 easy ways to do it. They can manually create individual users' accounts and groups directly on the admin page, the Google admin page that you would configure. The alternative is you might have an enterprise and they may export all other identities into a file, and then that file can be bulk uploaded and then used as a way to create identities inside of the Google Cloud. It's called a bulk upload. Or we can simply import accounts. So we can import existing accounts from either Cloud Identity or maybe say Active Directory and make life real easy. So we want to keep that in the back of our mind. Now, we have this concept of Cloud IAM and also Cloud Identity. So I want to make it very clear what these 2 things are. Cloud Identity is an authentication system. So that means Cloud Identity determines who you are or who you claim to be. Now, Cloud IAM actually does the permissions and for the user. So if we think of when you try to log in, Cloud Identity will say, yes, Cindy the cat, you are Cindy the cat. But the Cloud IAM says, Cindy the cat, you're able to access this one system, but not the other system. So kind of hope that makes sense from the system's perspective, what's going on in the interplay. So the key here is to try to make things easy whenever possible, to use more than one of these systems, use a layered approach to security. Everywhere we're using a layered approach to security, but understand there's going to be separate interfaces for Cloud Identity and Cloud IAM, and it's going to be a layered approach. But the point here is to be fairly flexible the way these accounts are created. Google offers a lot of ways. It could be manually done. It could be bulk uploaded. It could be imported from something else. Kind of keep that in the back of your mind. That's what we're really talking about these Cloud IAM and Cloud Identity services from Google. So if we think about this, let's talk about Google Cloud Directory Sync. So it's probably not going to be super feasible to be managing multiple cloud providers' identity. And the point is we have this concept of the Google Cloud Directory Sync. And what is it really doing? Well, it's doing a few things. It's giving kind of a centralized management environment to the user that's going to have what they need to actually access the system. It's going to come up with an automated sync, which is going to make it very easy, for example, to be able to synchronize our identities across our environments. And by doing so, it puts us in an environment to make it very easy to deal with IAM in our environment. So I kind of hope that makes sense of what we're dealing with Google Cloud Directory Sync. It's going to integrate very well with LDAP. And by integrating with LDAP, it'll connect to Active Directory and other directory services. And that'll make it easy to synchronize the information. And it'll be a one-way sync from the LDAP server to the Google Cloud. And it will be able to synchronize users, groups, organizational units if you're using them, aliases, profiles, even shared contacts from LDAP and Google Cloud Identity. So it's going to give you a lot of abilities to make it a lot easier to maintain your systems in multiple environments. And regarding provisioning users with Google Cloud Directory Sync, it can be customized. So it will support any kind of custom mapping of rules that are needed to settle the synchronization process. And the Google Cloud Directory Sync gives you a very friendly user interface that makes it very easy to kind of simulate your configuration before running the sync to actually prevent any kind of errors. So it's a pretty friendly, easy to use service that's doing these kind of things. So it's about getting your identities. As I mentioned, there's alternatives for provisioning users like bulk uploads, manual creations, third-party tools, even a software development, even a directory API, and there's software development kits for that. So there's a lot of abilities to do this. So let's talk about some roles we actually have as it pertains in the Google Cloud as we're dealing with cloud identity. Now, one of them is going to be something called the super administrator role. And I can tell you what that is right now. The primary responsibilities of that role is it will manage user and group account lifecycles and security settings within the organization. So that's pretty big there. That's why it's called the super administrator. The super administrator has full visibility into their own organization and can be given access of cloud identity and Google environments across the entire organization. So by default, you've got access to your entire organization, but you can be given access to others as well. And in multi-organization setups, this super admin can have visibility into everything. So this person, the super administrator, can manage cloud identity settings and see a lot of the resources. Now, because the super administrator role is big, you want to make sure that account is protected. So maybe you secure that with hardware encryption keys to prevent unauthorized access. Super admin controls typically bypass single sign-on and can authenticate directly with Google. So the best practice here is to limit the number of super admin accounts to 3 or 4 to reduce your security risks when possible. Maintain a backup security key in case one's lost. Provide a backup email account with 2-step verification for recovery purposes. And make sure there's not more than one super admin in an environment to make sure there's more than one super admin to make sure there's not a single point of failure. What happens if you only have one admin and something were to happen to them? So make sure there's more than one, but make sure there's not too many too. So let's talk about the organizational administrator role. Now that person's primary responsibility is to define IAM policies and grant IAM roles to other users inside of the organization, determine the structure of the resource hierarchy in the environment, and this person delegates key cloud responsibilities by assigning them roles to other users. So this person is still pretty big, but it's typically limited to the one domain. And permissions-wise, they cannot perform actions like creating folders unless granted access to the specific role that allows such functions. So it's more locked down than the super administrator, but it's still got pretty significant permissions in this role. So let's talk about separation of duties and role delegation. It's recommended that you segment duties or have a separation of duties between super admins. Minimize the risk of malicious activity, minimize the risk of accidental human error causing a problem, and typically delegate roles and responsibilities to ensure that no single user has extensive control over the environment. So How should a user authenticate to the Google Cloud? Well, we've got primary methods and we've got other methods. We can authenticate without single sign-on. Realistically speaking, a user can authenticate directly with Google accounts without using any kind of single sign-on. And this method's kind of the least common in today's world because it's just logging on, single username, single password, that kind of thing, typically not very strong. Now, we can do Google authentication with single sign-on via cloud identity, and that basically enables the users to sign in. The requests are checked by an identity provider, which is a great thing. We've got minimal overhead, and we've got synchronization this way about all our clouds and all our systems. Minimal impact to the user. So we can have single sign-on with an external identity provider. So we've got the users that are going to authenticate with the external identity provider, like Okta or ADFS or Ping Identity. And most enterprises actually do this because it's simple. You've got one big system that you're actually dealing with, and the cloud providers connect to that. It's very interoperable. It's very holistic because now we're dealing with a single third party. If we're using that, it could be an identity broker or a cloud access security broker, but whatever it is, we're dealing with one company to maintain things for us, and we can use it across our environments. Now, one thing that's pretty important is two-step verification, multi-factor authentication. It's almost mandatory for privileged users. So you kind of have to do it. So you want to implement two-step verification, multi-factor authentication, or at least two-factor authentication for any privileged accounts. Because any account that can delete other accounts or access sensitive information, what happens if that user goes awry? We're going to seriously have some problems. So we need to make sure. And we want to do any kind of risk assessments as well for unprivileged users to make sure that even they have two-factor authentication whenever possible. Now, how could we do it? We could use SMS, which is not going to be one of the secure methods. The challenge is it's vulnerable to hackers. If they steal the SIM card and you've got a text message, they could actually access your two-factor authentication. NIST no longer recommends using the phone for two-factor authentication, realistically speaking. So keep that in the back of your mind, but it's still better than nothing. Now let's talk about using voice. A voice print in the world of AI, how easy is it for AI to replicate voice? So let's think about other ways we can do it. So let's talk about other ways we can implement two-factor authentications. We can use backup codes, authenticator apps. We could do push notifications. So there's ways that we can do a little better. We start getting into authenticator apps, starts getting much more secure. So the key is these everything is still vulnerable to hackers that we're really talking about. But if we're dealing with an authenticator, it's a lot better than a phone, which can actually be hacked. So we've got lots of ways we can do these types of authentications. We can use hardware security keys as a secondary factor. This is the most secure. It is going to be a hardware key that's going to have hardware security. It's going to have great cryptography in it. And typically, these are going to work fairly well. And they're going to be fairly secure. There's a couple environments we can use for these kind of keys. But the point is they're hardware. They're very secure. And we can use that for two-factor authentication. And that complies with FIDO U2F, which is the Fast Identity Online Universal Second Factor Protocol. So two-step authentication tends to be very helpful. Now, the last part of IAM is auditing. Keeping track of the logs, who did what. And if we're going to maintain compliance with regulations, we're going to have to do some auditing. If we want security, we're going to have to do auditing. Sometimes in the auditing process, you find out that people have been in your systems and you didn't even know. That's called an advanced persistent threat, where people are in your systems constantly gathering information and you don't even know. So we have to constantly audit. Now, it'll be necessary to keep things secure. So there's places where we can do our audits. We can go to the admin tab and we'll have some user review settings. We have this user settings review, and we can monitor and review user settings to make sure that they comply with our policy. We can do tests of password strength if we're even using passwords in the first place, and we probably shouldn't be. We should be looking at audit reports that will give visibility into user logins and audit logs across our environments. We should be setting up custom alerts. So We get notified when people are doing things that seem or feel suspicious. So kind of keep that in the back of your mind. So if we have a user that has an account in the premium tier, they're going to get access to the Security Center, which theoretically provides advanced threat detection, and it will use advanced tools and features for detecting and analyzing potential security threats. And be fair, they're very good tools. But in a multi-cloud environment, you may want to use a different environment that manages everything, or you manage multiple separate environments. The organization has to make those choices. But we want to get visibility and insights. And the Security Center does a good job of that. It gives enhanced insights into security-related events and other activities inside of the cloud environment, and it tends to integrate fairly well with security operations and make sure that the cloud identity logs are routed to the security operations team, and it's going to make it very easy for them to do ongoing monitoring and analysis. Okay, at this point, we finished the cloud identity section, and we're going to get into the next section, which will be resource management.
Okay, we're back. Want to make sure we're here to see if any questions popped up, if there's an opportunity for any kind of clarification or anything else that needs to be. So, Chris, I'm not sure. Did any questions come up? I know you're behind the scenes. Do I provide any training on cloud sales? And how can a Google Professional Cloud Architect be beneficial for cloud sales? So, bear in mind, it depends what you mean. In our Executive Architect program, we provide a lot of training on cloud sales because that's more for the architect that's reaching that executive level. Maybe they're also going to be in sales. Maybe they're migrating towards a CIO. Maybe they're migrating towards a CTO position. Maybe they're migrating towards a VP of architecture position. In any of these roles, there's a lot of sales. So there is a lot of there. Now, am I providing account manager training right now? No, I have been thinking about it. I have closed some extremely large. I think the largest deal I ever worked with was $1.1 billion. So I've been thinking about putting together maybe an account manager or global account manager program over time. But so the answer is I provide sales for sales engineers, solutions architects, strategy consultant, enterprise architects, that level of sales. Now, when it comes to the sales, let's talk about what really drives sales. It's not a certification. It's your ability to solve a customer's problem. If a company has a retail website that's generating $1 million a year in net income, and you're able to create an AI recommendation engine, and that recommendation engine takes it from 1 million to 10 million, and the recommendation engine only costs $2 million, then you made them, basically speaking, $7 million with your architecture. That's going to sell. So if we understand our customers' needs and if we can find a way to build a business case to go solve that. If I have a hospital and I'm an architect and I can automate something or create some new technology that's going to increase the number of people that will survive and decrease deaths, I'll probably solve it. So the first thing we have to understand is we have to be relevant to the customer's needs. Do we understand this customer? Now, the next part of sales, bear in mind, is actually the exact opposite of what you'd find in a Google Professional Cloud Architect. It's actually being a trusted advisor. So if you want someone to sell someone to you, they should not have a bias of Amazon, Google, anybody. They should have a bias for customer success. Now, this is one of those places where vendor certifications aren't so great for you. Because if you take an AWS certification, it's designed to bias you towards AWS and make you excited about selling it. If you take a Google certification, it's designed to bias you. Which is why when we talk about the big heavy hitting certifications like TOGAF, or realistically speaking, CISSP, CCSP, CISM, they don't mention vendors. And even truthfully, if you were taking a Cisco certified internet expert exam, everything on that exam, you could basically swap the name and use it at Juniper or use it at Arista, and everything would be the same except for the command. So there is that. Now, the next side of sales is being able to quantify the customer's financial challenges. So if they've got $1 billion business problem and your technology is under $100 million, you can sell it to them. But if you can't quantify their business problem, you can't do that. Now, the next thing is understanding meeting the stakeholders. So going out there and meeting the stakeholders, getting the stakeholders' needs, understanding the stakeholders' pain points, for example. something that else would go into sales. And then a solution that aligns the stakeholders' needs along with the key business processes and key technology that's going to solve a problem, you'll sell. Well, assuming you've got the right presentation skills, the right executive presence, the right business acumen, the right CXO relevancy, knowing how to plan an account, all the steps of account planning that go in there, from qualifying to determining what's there. So yeah, that'll help you sell. Now, a certification like an IT certification, not so much, because these are more about the name of something and how do you call it. But so we talk about where you would do it. So let's say you're an account manager and you've got the kind of business acumen that we're talking about, MBA like business acumen, and you understand how to sell. You could say, oh, when I was younger, I have the CCIE, and the CCA really taught me about networking. I never forgot it. It's near and dear to my heart. You could do that, or you could say, well, because I took the Google Professional Cloud Architect, I understand the Google product set and its service as well. And that would also help you there. But this is more of less of a sales rep certification, which is why you see SVPs of sales that are earning $2-3 million a year. They don't have a single certification on their resume. They may have an MBA though. And then you see a VP at a tech company that earns about $800,000 to $1 million a year on average. They don't have any certifications on them either. And then you see a director of sales, and chances are they don't have any, but I bet you they have an MBA. Or if they don't have an MBA, they have MBA-like business acumen. So I think we need to understand where the certifications are great for getting you an interview. But when it comes to getting hard, it's all about your skills. Good question. They're a little off topic, but I love questions that are people really getting to think about their careers. In fact, if you have a lot of career questions, Chris, do this. Set up a time from 11 to 12:30 tomorrow where I can answer any career questions. We can do it from, say, 11 a.m. to 12:30 tomorrow prior to the 2 p.m. boot camp. And that way, if anybody's got any career questions, I can dive deep on it. How does that sound, everybody? If you like the concept, give me a hashtag or a thumbs up or a like or something like that, because I really do want to help. And Chris will drop a link for that as soon as he makes it. It may take him a few minutes to set that up. And in the meantime, let's get back into content and give me a hashtag Google Professional Cloud Architect.
In this chapter, we're going to discuss resource management from a scalable and a secure perspective. Now, this is going to be a big component of the Google Professional Cloud Architect exam, and there's a good reason for it. Organizations can get quite large, and we need a way to make them simple. We need a way to organize them and logically think about them and then manage these resources. And that's what we're talking about here. So Google has this resource manager, and it provides a mechanism to organize the things that you're doing on the Google Cloud, resources, folders, and provide policies to them like IAM policies. So it's going to enable us to create some security across a wide environment in a simplified manner. So I'm going to draw this out and show this to you and explain it to you. So the resource manager enables us to organize our environment. And at the top of our environment, what we have over here is we have something called the organization. And realistically speaking, this is going to be what you would consider to be a top level container. And it encompasses everything going on for the account, or at least the organization. So that means, whatever be virtual machines, containers, everything, storage, it's all going to be part of the organization. Now, next down, and this is for centralized management purposes. Now, next down the list, we have folders. And folders enable us to group what we're doing by maybe a business unit, for example, or by a team, or by an environment, or about a project, for example, that a company's doing. Not a project in the way Google would look at, but a big project that a company might be doing, like a new location overseas that's going to also have a data center, that kind of thing. But in this case, they wouldn't have a data center. But some big project you'd be working on, you might put under a folder. But in this case, we have at the top, we have the organization, the primary responsible structure, the parent, if you will. And then underneath this, we have the folder, which are going to be a grouping that you can make of something significant from the company perspective. Could be a business unit, for example. And then underneath that, we have what we call projects, or at least Google calls projects. And these are going to serve as a container for resources that are going to be used by your account, like virtual machines, for example. And then resources are what's inside of the project. And multiple projects can be inside of a folder, and then they're there for the organization. And here's the reason why. You can apply a policy at the organization level, and it can be pushed to these other environments, at least some kind of IAM or security policy. And that can really help you manage security in a very simple and a very scalable way. So it's that hierarchical IAM policy that we're trying to get out of these. And the key here is the inheritance of policies. So I'll draw it out, or at least explain it one more time. So the key here is we can put a policy here, and then the folders will inherit that policy, and then the projects will inherit that policy, and even the resources will. So if you think about how hard it would be to manage everything separately, but the ability to set it up at the organization level and have things inherited, that's the scalability. So it enables a lot better access control. And that's what we're really talking about. Managing permissions at different higher levels. We can manage it at a single level, or we can manage it at the top level. So we get very granular and have a lot of opportunities. The resource manager also enables programmatic management. So that means managing things over, say, an API. From a change management perspective, we can look and see what changes were made. We can look at, say, the change history, and that will enable an organization to identify a change or a project that was recently deleted. Maybe we had an accident, somebody made a change and it caused a problem. We can find that change from in the change management logs here. We also have the ability to undo changes. So let's say we make a change and it breaks something, we can revert back and undo those changes we made with regards to the resource manager. And sometimes that can be a very good thing. So it's going to be important to organize your environments well. And if we organize it correctly, it'll be logical, it'll be simple to manage. Otherwise, when stuff starts getting sloppy, and it puts us in an environment where systems are doing things and we didn't organize them well and our architecture isn't logical, how do we change them later? And when it becomes too hard to have all this stuff and to change things later, they typically call it technical debt because you made an architectural choice that didn't work, or that worked tech-wise, but all of a sudden it's a little icky, and now in order to change it and fix it for scalability in the future, you're going to have to spend a lot of money to fix it. So we want to make sure we don't get into sloppy environments in our architecture. We want to plan things properly. The other reason we like the resource manager so much, and Google's pushing this resource manager and testing you so much on it on the professional cloud architect exam, is it's going to be really necessary from a governance and security perspective, from a scalable perspective, to make sure that the policies are applied. And it's going to make it a lot easier than trying to apply a policy every single time. Now, we can still apply a more specific policy to a resource, and that's great, but we can provide generic things that we need to do that are going to get us the way that we're secure enough. And then if we need to lock something down even more, then we can do it at the resource level itself. So it enhances security and governance, and it promotes rapid innovation, because if your organization is clear and it's logical and it's laid out and you know where your resources are and what's talking to what, now all of a sudden when you want to make a change, it's easy because you're already ready to go. If you don't know these things, you may have to analyze everything, figure it out, and fix bad architectures in order to be able to do things. Now, let's talk about legacy infrastructure. So, like in a data center, we can have the most advanced infrastructure in the world that's every bit as good as the cloud computing environment, basically using the same servers, same routers and switches they are, even if they're made by a different company. So, and then we even have more control. But some on-premise environments contain very outdated things. And sometimes they have outdated things because they're still a critical part of the business. And sometimes that makes it more challenging to manage. And sometimes it doesn't. So, with architecture, we have to weigh things as we move forward. And it's not the best technology or the most innovative. It's what's best for the business. But for the purposes of your exam, you should probably know that on-premise environments may have remnants of older things which are harder to use. So keep that in the back of your mind. So if we don't understand the infrastructure and that we change it, the risk of something is so great. which is why, a cloud architect like me, I might need a cloud architecture team, and it may take us 6 months to even figure out what's going on with the client. By the time we're done understanding the business processes and business architecture and all their technology infrastructures and the way the users need to work in the future in order for the architecture to be successful, that could be 6 months just to get that kind of information. So, the more organized things are, the more clearly understood things are, the easier it will be to make architectural changes. And we often want to make architectural changes for innovation purposes. So, keep that in the back of your mind. So let's talk about the benefits of a clean, clear, and organized cloud environment. It reduces risk. As we get rid of unnecessary things or insecure things or outdated things, their risk of new incidents or security incidents is significantly minimized. It also reduces risk because when we make changes, they're less likely to have a problem, because if we don't know what we have, we can't assess the impact of the change before we make that change, which means we could make a change and it can affect another part of the system if we don't understand the system correctly. Now, one of the things some companies like is they like to keep their top engineers excited by working on some of the latest technology. I don't ever recommend that. I recommend designing the architecture that's based upon what the business needs best. But for the purposes of your exam, the improved developer experience may make people want to work for you be more likely to want to work for you. And others would argue that if everything's well organized, your developers will do a better job. And that is absolutely true, because it reduces the risk and when you know what you have. Having an environment clean and having an environment well planned and having the environment that's architected for agility and scalability enables rapid growth or rapid changes in the business perspective, and it promotes a culture of innovation. So that's a lot that we can get out of the resource manager. It helps us do these things that we want to do. It's a tool for us. And, as architects, our design is to help the business. Now, what tool we use to do it? Well, it's the one that does the job best. But the more information we have, the more organized things are, the easier it is to make that determination. So we get very good visibility with the resource manager, and the organizational hierarchy enables us to manage and view resources easily. So we like that. From a security and governance perspective, it's a lot easier to say we need to meet a certain specification by going to the top and applying a policy here and having the other folders and projects and resources inherit that policy than it would have to be for us to set up a policy every single time, one at a time. The adaptability. So if the architecture is simple and it's scalable and it's properly designed, it becomes very easy to add new services or create changes and add new things because the architecture is designed for it. If the architecture is designed for today and the people that planned it out didn't think about what's needed tomorrow and how it would grow tomorrow based upon the business's goals, then it's very hard to make changes. And sometimes in order to get there, you'd have to go where you're at. You'd have to do a new project, what's called a transition architecture, to get you to point B. And then you need a new architecture project to go to point P from point C, which you might want. But if it's designed properly, you might just be able to make the new changes. So, resource manager will help with that because it's what we're trying to do from an architecture perspective, and it gives us better information. The resource manager gives us good information so that it reduces risks. And that's always a good thing. It reduces risk of a security issue because we can see what we have more clearly. And we can make sure we didn't forget certain things. And again, it reduces risk of deployments and new architectures because you know what you have. And you're not making changes to things that you don't understand. So I'm going to talk a little bit more about those resources and their components. And I want to do it to make sure you understand the billing and the such. So when we look at this hierarchy, we're looking at where the components are. At the lowest level, these are the resources the team is setting up. This is the object storage that you'd be thinking about. This is your virtual machines. This could be your containers. All the things you're actually using is the resource. And the key here is that each resource is parented by a project, which inherits the permissions that have been applied to the project. And it makes it a lot easier. Now, one of the things we're going to get here is we're going to get detailed billing here, related to the actual projects, related to the actual business unit. So if we're dealing with a company that wants to charge each business unit back for its tech services, it becomes very easy to do. It also helps an organization from a planning perspective. They could say, this business unit is using this much tech, and this business unit is using this much tech, and they can see, is the technology making a big difference in the business? Now, when we go to the project level, it's really a grouping mechanism for resources. And it's going to be mandatory for managing Google Cloud services. But the key here is going to be each project will have its own unique project ID, project number. It's going to have a mutable display name and a lifecycle state. So you're going to get some information about it as well. At least when you look at it, you'll get some meta information that will help you understand what it is. And of course, here we have a logical grouping of resources, and we can do it based upon functionality and access control. So it makes it very easy to talk about controlling access to resources and security. Now, a little more about the folder level. Now, these are used to group similar projects. So that's one way we can do it. And what does that typically mean? It means that we can apply a policy here that the projects will inherit. So that, again, makes it so much easier. It acts, realistically speaking, as a policy IAM point. Because, everything, we can create a policy that is inherited down. Now, at the organization level, this is the root top level element of this resource hierarchy. And I know I talked about it earlier, but now I wanted to give you a little more information about each section after first explaining it at a high level and then talking why we need these resource manager type things in an architecture perspective. So now let's talk about the organization. That's the root. That's the top level element. Here's where you're going to get your centralized visibility and control. And you're going to see it for all the resources in the organization. And this is going to be automatically provisioned when the first user with a Google Cloud Identity, for example, might be set up, or Google Workspace when this occurs. So this is going to be critical for resource management, lifecycle management, identity management, and it's really going to help with ensuring accountability. Now, the point here is to be able to create an organizational policy and to be able to set the constraints for a project or a folder or an organization and enforce it and ensure that consistent policy. And we can apply any type of constraints we want. For example, we can evaluate against a list of allowed values or non-allowed values. Maybe if you can think of an example of like an IP whitelist or an IP blacklist, whitelist where you allow certain things and blacklist where you disallow it. We can use Boolean constraints that can govern specific behaviors with like a true or false setting. For example, disabling the ability to create a service account. And a service account's that typically used, especially in the Google Cloud, for one system to talk to another system. It's a type of IAM account. And the key to remember here is that organization policies are not retroactive, meaning that they do not automatically apply to existing resources. So you're going to have to manually remediate something if you have existing resources that have violated a policy that you just set. So let's talk about some best practices for structuring, your Google Cloud environment. Plan the organization with future scalability and changes in mind. Assume that everything could change. So when you design an architecture, not only are we talking about this layout, but we're designing the network to make sure that it meets the needs of the future. Will the network have capacity? Do the routers have the capacity? Is it a simple add a link to move forward? Or are we going to need to change routers or change many different technologies along the way? Just for the network, we'd be thinking routers, routing protocols, and what do we need to do to tune it? And how is that going to grow? And then how would we connect to various environments? What would happen if we bought different businesses, for example? What happens? How would we manage different addresses if we dealt with one company versus another company? So we have to plan every element of this. The network plan is based on that from the network architects. The security architects need to focus on security now and how it would adapt to changes in the future. So everything we do in architecture is planning for the future. That's why architects aren't touching the technology. It's a pure planning role. So plan with the future needs in mind. Use a lot of projects to facilitate changes in access control. And that way you can apply it on a simple and scalable way and make sure your access control is going to be where it's at. Separate your resources. Align projects with specific applications or environments or business functions. Anytime you can create a separation of duties or a separation of access, you're increasing security. You can use automatic project creation, with an infrastructure as code script. You can automatically create your projects and ensure consistency and ease of management. And when possible, for the cloud engineers and the DevOps engineers that are deploying resources, it's much better to use a good infrastructure as code script to make sure that there's no manual errors. Now, here's the thing with automating anything. If the person who's doing the automation doesn't understand what they're automating, they can break things as fast, if not worse, than they're actually setting them up. So the people that are writing that infrastructure as code script need to be sure they need to understand the rationale, not just how to do something, because they need to be solid and they don't make mistakes. Now, when you're dealing with things, let's talk about, we should be able to protect critical projects. And if we've got a critical project in a production environment, we need to make sure that it is protected from somebody, say, accidentally deleting it. And that's why we're talking about such security policies here. And obviously, for more information on the resource manager, go to the Google Cloud website, learn a lot more about the service.
Okay, well, welcome back. We are here. We can answer a few questions. After we answer questions, we've got 2 relatively short labs for today. We may finish a few minutes early. As the topic came up, I'm going to come tomorrow at 11 a.m. Eastern and do a career question and answer session. And on Thursday, I'm going to have a how to become an architect webinar. And I will spend 2 hours getting real strict and exactly what we do as architects, exactly every skill you need, what hiring managers are looking for, how you bypass HR. So please join us. We run one every Thursday. That'll be on Thursday this week. We actually have one more video content to go to and then the labs for today. But Chris, it looked like a question or 2 popped up. So let me get to these questions before we get to the next one. What would a good focus for cloud architects be? As many companies seem to advertise their job description for an application. So I want to do 2 things. One is I want to talk about why all these job descriptions are completely inaccurate. And the other thing that I want to do is I want to really give you the real cloud architect job description. So this is something I'm going to be releasing very soon on LinkedIn, but I drew it, so I thought I would show it with you today. So here's the reality. Let's say I want to hire a hiring manager. So I'm the hiring manager and I say, I want to hire a cloud architect. Here's what occurs at 90% of all organizations. I call HR, I fill out a form that says, I'm going to hire a cloud architect. Now, HR says, great, Mike, we're going to go through 4 to 6 weeks of approvals. And in the meantime, HR, us, who knows nothing about the job, we're going to create a job description for your cloud architect role. So because I told HR I want to hire a cloud architect, HR says I have to write a job description for the cloud architect role. Only problem is HR knows what to pay you. HR knows what your benefits are, but HR doesn't know what a cardiothoracic surgeon does or a cloud architect. So what HR does is Googles a whole bunch of silly job descriptions that exist on the internet and says, none of these really say cloud architect, but if I add all 10 of them together, now we've got a new job description. So the new job description that you've seen now lists elements from 20 different people's careers, and none of the skills are related to being a cloud architect. And that's why we typically have this mismatch. Now, the separate problem occurs is by the time I actually find somebody that I can actually hire as an architect, because everybody's trained to be an engineer when I wanted an architect, 5-6 months later have passed, and I don't even need the person that I was hiring in the first place. So now I use the requisition for the architect to give him a completely different job. So that's why job descriptions are bad. So here's the good news. You don't have to believe me. What happened is Gartner went and asked the chief information officers, what do you want in a cloud architect? Now, this is a direct screenshot from the article I gave you, but listen to what the management said. I want a cloud architect that can lead the cultural change for cloud adoption. Now, that means creating a team, examining stakeholders, asking the stakeholders' needs, learning what the stakeholders need, that creating training materials, that's leading the cultural change for cloud adoption. Developing and coordinating a cloud architecture is understanding the business, understanding the client's landscape, the client's challenges, and that's going to take you to build a team of 15 to 50 people. That's developing and coordinating the cloud architecture. Now, then the last part is developing a cloud strategy and coordinate the adoption process. So do I make the single cloud, hybrid, multi-cloud, what have you? Well, that's the three things we do in our job. So I'm hoping you're starting to understand. It's going to sound a lot like an executive, because it is. Now, the other stuff we do day by day is find talent with the necessary skills, assess application, software, and hardware, create a team. They call it a cloud broker team, establishes best practice for the cloud. So every new user will be using this form of IAM. Every demilitarized zone will look like this. Select cloud providers and vet third-party services. Which cloud providers do we use, and which other vendors do we use? You typically have about 50 vendors. Oversee governance and mitigate risk. Develop privacy incident response procedures, and manage costs. So the key is that's what we're doing. So that's going to take a combination of business skills like CXO relevancy, sales, executive presence, the ability to profile accounts. It's going to take networking knowledge, security knowledge, identity knowledge, compute knowledge, storage knowledge, security knowledge. And you know what we'll do? On Thursday, I'll give you an entire list of them. In the short term, Anthony, my team wrote an ebook on the skills you need to be a cloud architect, and we'll drop that in the chat box. So Anthony will drop an article on everything you need to know skill-wise. I'll come online tomorrow, Tuesday. Tomorrow and Wednesday, I'll do some HR stuff, some questions and answers for cloud careers. And on Thursday, I'll spend 2 hours. I'll go over the role. And I can do anything I can on this webinar. We'll go over the role. We'll answer questions. If you want me to look at your LinkedIn profile, I want to see if you're ready to be hired. I'll even give you a mini interview there and tell you if you're ready or not. So all that's free on the Architect webinar on Thursday. And I do this every week. Hope that helps. Because it's a great job, and I want everybody to have it. And I hate to see so many people get held back from this role because they confuse it with an engineer. And it's a great, great, great role. To what extent does resource management vary by major cloud providers? It's all very, very similar. Actually, if you take the CCSK course that I taught, which is on this channel, I actually break it down how AWS does it, Azure does it, Google does it, and you'll see they're nearly identical. So all pretty much the same thing. So cloud provider is somebody that's renting you space in their data center. So for the most part, all clouds do the same thing because they've all been offering the same data center services because there's nothing else they can offer. Data centers have changed very little since the technology. Now the speeds have changed. We went from single core CPUs to 192 core CPUs. And we've gone from systems with 1 megabyte of VRAM to systems with 8 and 10 terabytes of DRAM. We've gone from a GPU that can calculate very little to some crazy GPUs that can calculate a whole lot. But all in all, it's going to be very similar. Now the commands, very different. The interface and the way it feels, going to be very different. But the actual underlying things, nearly identical. It's a really great question there, Darnell. And that's why I say if you learn the cloud, and I mean truly, truly learn the cloud, you'll know all clouds. But if you just learn a cloud, you won't know that cloud. So we've got a 30-minute video and then 2 short labs to finish the day. Now, tomorrow we're going to get into some geeky, techie stuff on the network. So these labs are going to be tomorrow a lot more fun. But these concepts are so critical. And as architects, we don't touch the tech. We talk about it. So I wanted to give you as much conceptual work as I could because I really want you to be successful. I think the architect career, the cloud architect, this is enterprise architect, solutions architect. These are some of the best jobs in the world. And I've loved them for my 25 years. And I want you to experience the same. Give me a hashtag so that I know you're here. If you're having a good time, maybe give it a like. Subscribe, invite a friend, really share these free materials with others because we really want to help. And Chris, let's get back into the content. Give me a hashtag, Google Professional Cloud Architect, so I know you're here.
This section, we're going to talk about cloud identity and access management. And that's going to be another big component of the Google Professional Cloud Architect exam. If you'll recall, we talked about cloud identity earlier. And cloud identity is predominantly the authentication piece and determining who the user is. Now, I know when we talked about that, I actually gave you a lot more about IAM because I wanted you to understand identity and access management. So because I did that, this section is going to be a lot easier. But we're going to go over the Cloud IAM, specifically the Google version, and how it can work with regards to authorization. So IAM is absolutely critical. In general, the human element of our business is often the weakest link. A whole lot of cyber attacks result from somebody that has too many privileges and sometimes accidentally makes a mistake, or we have the wrong person using the system. And a lot of that can often be fixed with better authentication, but also much better configuration management. Now, with regards to IAM or any kind of security, we have to always use the principle of least privileges. The principle of least privilege is give people access to only what they need to do their job, the resources. You may also hear the term need to know. That's slightly different, but almost the same things. And that means don't give information to people that don't need it, nor need to know it. Now, they're very similar concepts. And when we're dealing with security, in many cases, we're going to be talking about the principle of least privilege, or again, that separation of duties, which we talked about before, which is don't have one person responsible for everything separated amongst multiple people. Because if you have one person that's responsible for everything and then they do something funny, like embezzlement, there's no one to even catch it or notice it. And risk management is going to be critical for all businesses. And risk management, which is way above the scope of the Google Professional Cloud Architect exam, is about identifying the organization's assets and what they're worth and the risk of being compromised, for example, then determining what you would do. Do you mitigate the risk, transfer the risk, accept the risk, that kind of thing? That's more risk management. And access management is one significant component of risk management, because how do you reduce the risk? You implement controls. And one of the controls that we're typically talking about here is IAM. Other types of controls could be things like firewalls. Other controls could be physical security. There's a lot. Other controls could be input validation, or a lot of different things. So security is all about implementing controls to meet the needs of the security policy. And as security architects, we create that security policy and, of course, the security architecture. But understand that human element can be a real risk there. Now, we're going to talk about Google's IAM platform, and it's called Cloud IAM. And it provides good enterprise-grade access controls to authorize actions on cloud resources inside of Google. It enables full visibility and fine-grained control. It enables you to centrally manage all of your access control across your Google Cloud resources. You may have to think, what would you do in a multi-cloud solution? But generally speaking, with Google Cloud IAM, it really provides excellent management of the Google Cloud resources. Now let's talk about IAM policy management. We can manage IAM policies, and we can do it via the Cloud Console, the thing you click with that looks so pretty, the API, or the command line. And we have to think about strong access management. We have to make sure that only the people that need these high privilege roles actually have them. And we want to make sure that people don't have more privileges than they need. So we're going to align this heavily with our authentication, authorization, accounting, security model. So let's talk about some IAM considerations. So user experience with IAM should be designed to allow users to perform their jobs without too many obstacles, because here's the reason. You make the passwords too complicated and people put sticky notes of the passwords. They write a little folder on their computer that lists all their passwords. We don't want people to be doing that. I mean, there are password managers that can be used, but what happens when the password manager gets hacked? Like a recent example just happened. So we have to think about all of these options. So security teams, realistically speaking, need to be engaged in the IAM architecture. Now, in a big environment, a big global environment, we'll actually have IAM architects and security architects collaborating on these together. In smaller organizations, the security architect may do it all, the IAM and the security. The policies that are going to be created with IAM need to align with the enterprise security policies and help monitor it. So when we security architects design that security architecture, part of that architecture is how people are going to monitor and manage these systems. And the IAM systems can help here because there's auditing after the fact. And when we deal with an enterprise, new cloud organizations may need to revisit and think about their security policies, especially as they evolve to the cloud, because there are more challenges in the cloud for security, and there's a lot of challenges and data sovereignty and laws, and there's so many more challenges in the cloud. And I'm not saying the cloud's not bad, but you really need to think about this. Now, again, that's way above a Google Professional Cloud Architect. Those types of challenges, obviously, we teach in our Security Architect program. That also covered fairly well in the CCSP exam. And there is a CCSP exam or certification training bootcamp, an entire bootcamp on this channel. So I suggest checking that out to learn more about it. That is absolutely some pretty important content for anybody working with the cloud. So we're going to talk about the specifics right now, and we're going to be talking about IAM members, roles, and policies. So let's talk about what these things really, really are. Let's talk about members. What's a member? A member is a human user. So I like to think of a member, at least when I view it, as a person. And that's the way I always view it. Now, a service account, if you're a Linux user, you may be familiar with service accounts, but a service account is when one system needs to access another system. And that's going to be what's called a service account. I'll give you an example. So we might have an application server. And the application server might need to talk to a database. And what you typically do is you create a service account that enables these two to speak together. Now we have the concept of a Google group. And I'm going to show you what a Google group is. And a Google group is just going to be a group of accounts. So what we're going to have is several accounts under that. Oops, bear with me. Didn't cut. And that's realistically what we're speaking with regards to a Google group. And the Google Workspace or the Cloud Identity domain represents the full domain that can access these resources. So anything that can access the resources is the full Google domain. Now, every member is going to need some way to identify them. You know, in life, we have our name, Michael Gibbs, right? But somewhere along the line, the cloud provider is going to need some way to identify, who the members are. And that's typically identified by email addresses for accounts and groups or a domain name for a domain. Now, when we talk to about members, and remember, members are people, we're going to create a role, which is going to be a collection of permissions that define what operations that member can do. And that role is going to grant a member, the permissions. So I know I walked through what role-based access control, but I want to make sure this makes sense to you. Now, this is the way role-based access control typically works in most organizations. So let's say, for example, we have to hire a new person. And in this particular case, Cindy applied for the job. And for any of you that have ever had a cat before, you know that the cat dictates your life, tells you what to do, where to do it. So, of course, when Cindy applied for a job, Cindy was hired by HR as a manager. So the HR systems typically integrate with the IAM systems. And as soon as Cindy's hired and they create a job for Cindy Gibbs, it usually creates an account that lists manager because Cindy was hired as a manager. So now what we do is we create a manager role, and then we give the manager access to the systems they would need to do their job. So in this particular case, let's say we have Cindy and we hire her as a manager. Cindy's got some goals as a manager. Now, Cindy loves tuna. So as a manager, Cindy wants to be able to give bonuses to their employees if they bring in fresh tuna for her each day, because she's going to be really happy about that. So Cindy needs access to the bonus system. Now, Cindy also knows that if she's going to send her workers to go get sashimi grade tuna each day, what she's going to have is they're going to have to be able to put a credit card in, pay for it, and then Cindy's going to have to reimburse them. So she's going to need access to the expenses system. And Cindy also knows that she wants to be able to give bad ratings to the people that don't get her sushi or shrimp or tuna because she wants to be well fed. So therefore, Cindy will need access to these systems. Now, let's talk about the sales engineers. When they are hired, they are given a set of permissions. But for example, maybe they need access to the sales materials, documentation, templates for presentations, for sales presentations, maybe documentation that could be used with RFIs, RFPs. So, of course, we need the sales engineers to get access to those sales libraries. And maybe the sales engineer needs lab access to mock something up and test it. So you'd see the sales engineers would get that, but we might have sales reps that only need access to forecasting machines and CRM machines and a few others. And that's what we're dealing with role-based access control. And now remember, roles are for people. So we grant the role, we grant the role, we grant permissions to the role, and then the next thing we do is we add users to the role. And that's role-based access control. So that's what we're really talking about and how we would do things. So we can create something now called the IAM policies. And these are going to be configurations that are going to bind members and roles together to enforce access control. Now, the point here, or the purpose, is to ensure that only approved access patterns are going to be allowed. And we're going to define who can access and what they can do. So I hope this makes sense, the way these IAM policies could be applied. Now, we can also apply IAM policies to resources like projects, folders, and organizations, which we just talked about in the last section. So we are able to apply these IAM policies of who can do what, for example. And we can do it at a big level to make it easier in a scalable way. So it's going back to groups. And groups are logical containers or groupings of one or more accounts. Going back to this diagram to show again, because now there's a couple of these terms and they kind of they're kind of funny, at least from my perspective, as they're marketing terms, except for like the service account, which is widely used in the industry. So, and every company can use their own terms for these types of things. So the groups, remember, are logical groupings of one or more user accounts. And it's to provide simple access management by defining roles for the group instead of individual accounts. So I hope that made sense. That's what we're doing, role-based access control. And groups are going to be created and managed in Cloud Identity. Now, we talked about service accounts being before, and service accounts are for one system to access another system. So going back, we might need a service account to run a batch job, process a transaction, integrate to an external system. For example, we could be running code executed in a Google environment, but it could be under a specific service account. So the key here from a management perspective is to apply principles like separation of duty and principles of least privileges, and to ensure oversight and the management. So whether it's a person that we're dealing with, whether it's a group, or whether it's a service account, we don't want to apply more access than is necessary. So let's talk about the service accounts owner. And this means programmatic accounts in Google Cloud that are going to be used to be automated without human intervention, still maintaining traceability. So the point is, with a service account, we still know that they're talking to each other. And this is for applications to talk to applications. Now, when it comes to role assignment, service accounts can be granted roles and privileges to perform certain actions or resources, just like any other account. When we think about it, these are ideal for automating repetitive tasks, such as processing transactions or uploading data to maybe an object storage bucket or an environment. Because we can automate it, we can make it good, and then we can apply a security policy. And that's realistically what we're talking about. And service accounts can be used to run workloads in your on-premise environment and have them then integrate with the Google Cloud API. So service account, if you're from a Linux background, that hopefully makes a lot of perspective to you. If not, I hope it still makes sense. So think about key management. So anytime we're dealing with encryption, we're going to have keys. Anytime we're dealing with any kind of security, we're going to be dealing with keys. And how do we keep our keys? Well, we could let the cloud provider manage our keys for us. And when we let the cloud provider do all of our key management, in this case, it would the management would be done by Google. They would typically rotate your keys weekly, and they're typically in an environment where they're non-downloadable. So the cloud provider is doing all your keys and they're maintaining the security for you. Now, that's fine. Now, we may have some users that have extreme security needs where they need to manage things on their own. And this is, of course, possible in all cloud computing environments. And this is the user-managed key, and this is where a user is going to create and manage the keys. Now, because key management is not that easy, it's going to require careful planning, and when are the keys rotated, and where are they stored, and where are they distributed, and when do you revoke them? So, you can manage it yourself, and many high-security organizations do, but they need people that really understand this. The GCP managed keys is kind of the easy button because they do everything for you. So we have to think about key protection. Now, if we've got to protect any kind of keys we have for authentication, imagine we have the most high security environment and the keys are just on a table. So we just take them. So imagine that. So we might, if we have a hardware key, we may have to put that hardware key in a safe in a secure building. So we have to think about how we protect those keys, or we use key escrows or things like that. So let's talk about the kinds of keys that you can use for managing service accounts. The Google ones and yours. In many cases, these cloud things are the same choices you would typically have, but they have a version that you can use. We have to make sure that no matter what we're doing, we rotate keys. Have to. And there's lots of third parties that can be an escrow or a vault for your keys. So generally speaking, we want to use short-term temporary credentials, like an OAuth 2.0 token or an OpenID Connect token. And we want short-term elevated privileges. And here's the thing. If I change my password every 90 days, and I usually use things much more secure than password, let's say I change it every 90 days. Let's say the first day I change it, immediately someone gets access to my password. Now they could use that password for 89 more days potentially. That's a pretty big problem. But if we use a short-term credential or a temporary credential that might expire in a day, the worst case it could be is the hacker had access to my information for a day. And if we change them once a minute, they would only have access to the ability to do damage for once a minute. Now, obviously, the more times we do this, the more overhead. So, and the greater the challenges would be with scalability. And the less frequently do it, the easier it will be. But of course, the less frequent we'll do it, the change keys, the more damage that can be done. So that's going to be an architecture trade-off that you'd make in the Google Cloud, the AWS Cloud, and even your data center. These are the kind of things we architects plan on. Just remember, security service accounts are really important because how else would you connect one system to another system? But we have to manage these service accounts very, very well. So let's talk about the difference between default and custom service accounts. The default service account is automatically created. It's generated automatically for Compute Engine instances when a project is created. There's default permissions, which are typically assigned to a privileged editor role, which is far too permissive for what you want it to be. But most systems come up far too permissive, say they're easy to access and easy to set up, and then you have to lock them down. For example, you'd have to if you had a web server, you couldn't just use the standard operating system. You have to lock it down, remove unnecessary packages, close various ports on it, and put some endpoint kind of protection on it. So you'd have to harden things that you typically do, because everything comes up too open for security purposes, but for convenience purposes. So typically speaking, the editor role, the privileged editor role, is going to be far too much privileges for most people. So it's not going to be recommended because of the broad permissions, and using this can kind of lead to excessive privileges. So you might want to change it. Now, we have to think about the dependencies. Instances rely on these service accounts to access other Google Cloud resources. So we have to be very careful when we modify or delete something, because if we don't know what dependencies exist and we just delete something, we would break it. So that's why we architects plan it out carefully, and we typically create great documentation. So when a cloud engineer or an operations engineer is managing it, they know where to go and they know what they ultimately have. Now let's talk about a custom service account. Now, this you will be using, and this is where you're going to be manually creating it for specific applications or purposes. Now, here you're going to get very granular with regards to your permissions. You're going to have very precise control over access, and this is going to enable others to adhere to the principle of least privilege, separation of duties, and everything else that you want. And this is going to be fairly versatile because you can use it for a wide variety of applications, including those running on premises or in the cloud. Now, the best practice here is going to be to delete the default account and create your own with the permissions that you typically need. Now, I talked about role-based access control. We talked a lot about roles. So let's talk about the types of roles that you can use in the Google Cloud. So one of the role types we have is what's called a primitive role. And these are your legacy roles. These are super basic predefined roles with broad permissions like owner, editor, and viewer, that you typically think about with regards to sharing like a file or a folder on a hard drive. Pretty high level type permissions. Now we also have some predefined roles. And one is like a service specific type of a role. And that's going to be a predefined roles that are created by Google, and they provide fine-grained permissions, and they're designed for certain reasons. So, the way AWS has, to certain specific types of IAM policies that are pre-made for certain things, this is realistically speaking the same thing. For example, you might have a role like a compute instance admin, and that will have specific permissions related to managing the virtual machines or compute engine instances on the Google Cloud. And this is often recommended for common use. It's best for standard roles that are commonly used across various projects. Now, let's talk about custom roles, and this is going to be really critical. Custom roles are going to be created by the client or by the user to meet specific business needs. Now, here we can tailor the permissions. We can create roles with a very unique set of permissions that may not be covered in a predefined role. We can get as granular as we need. So most organizations have custom roles that they're using. Okay, so let's talk about some really neat features, some key features that we can actually deal with when we create IAM members, roles, and policies. We can use something called attribute-based access control. So normally with role-based access control, it's that user. You saw how Cindy was a manager and she needed access to the bonus and the expense systems, for example. In this case, we can look deeper. So Google gives us the ability to do what's called attribute-based access control, and we can look at more details, such as the time of day, because maybe the user should be accessing a resource during the day and never at night, and if that's the case, disallow it at night. We can look at things like the IP address ranges. For example, we can restrict access to a certain subnet or a certain prefix range, and by doing so, only allow a certain set of users to access the system. We can define how long, for example, a user can stay in a system, and we can put these conditions in something called IAM role bindings, which is how the roles are actually completely bound to actual system. So if we think about this, the way with IAMs, how is it going to be implemented? It's typically implemented in something called the custom expression language. And that's going to be used to define the expressions that are going to specify various conditions within an IAM policy. Examples of conditions could be time-based access, like a user can access from, say, 9 to 5 or 10 to 6. They could be location-based access, like only allow users from the U.S. or only allow Florida users. Or we've got a business in Palm Beach County, Florida, only allow IP addresses inside of Palm Beach County if we wanted, or temporary access for a short period of time. Now, from an accounting perspective, and that's the last part of that authentication, which we talked about a lot with cloud identity. We talked a lot about cloud IAM and its authorization. So now let's talk about accounting. And that's to be able to see what happened and then audit it later. Because auditing is going to be critical for ensuring that the identity and access models are secure and they're actually working. So where are we going to get this kind of information, be able to look at things? Well, we're going to have several kinds of audit logs. We're going to have the admin activity audit log. And the admin activity audit log is going to track API calls and administrative actions that are going to modify configurations or metadata. And of course, metadata is data about data. It's descriptive data that helps you understand something better. And these logs are going to be generated when an IAM policy is modified. So we definitely can look at the admin activity audit logs. Let's talk about the data access audit log. So we can record all these API calls that are going to be there that are going to be looking for data, for example. So we can you record these calls that read configurations or metadata or even a user-driven API call on resource data. So the key here is to find out what else is going on in the data audit log. So this is going to be typically disabled by default. Because it's typically can become a pretty big environment. It can get costly. So if it's an environment where security matters, you definitely want to enable your data access audit logs. And of course, we'll get our system event audit logs as well that'll capture administrative actions that'll modify resource conditions granted by systems rather than user actions. So because we have all these systems that are going to be talking to other systems, we need these kind of logs. Now, we have to also talk about configuration monitoring and management of that. So imagine an environment where anyone could set up any configuration they wanted. We could have one user that can set up a web server and they've locked it down, they've tightened it down, and it's perfect. And we've got another user that doesn't even know what server hardening actually is. Where one user wants to use this version of an operating system and this application, and the other user feels like this and setting their permissions anywhere they want. Well, that's a great way to get hacked. So we have to see what's going on with the configurations. We want to come up with stock configurations. We want to simplify. We want to make sure the configurations we have are good and strong and secure. And we want to monitor that and make sure that the configurations stay this way. So we're typically going to be having to monitor these things. Misconfigurations, by the way, by customers are the most common cause or the leading cause of cloud security breaches. So a lot of cloud security breaches, and so many of them come from accidentally just not knowing what someone's doing. Misconfiguration. And it's usually not the person that knows and understands the underlying concepts and technology. It's usually the person that just does a lot of hands-on stuff but doesn't know the what or the why or behind the how that they're actually doing. Now, there's going to be really good third-party solutions for this kind of environment, monitoring and compliance. Prisma Cloud by Palo Alto Networks, for example, offers tools for identifying or correcting cloud misconfigurations. There's the Forseti Security, which is an open source option, which provides scanners to detect misconfigurations in cloud environments. It's got customizable scanner rules, and you can available on public GitHub repositories. And there's just scanning functions that we can use. For example, ensuring that there's no all user IAM policies, for example. So the ability to enforce account key rotation, restricting access. So you've got to be able to make sure that these things are going on. Okay, well, Leo and I are back. I think there might be a question to answer. And then Leo's got some entry-level labs that we're going to have some fun with today. Tomorrow's Leo's labs get a little geeky, and they're going to be really fun. So I'm looking forward to them, too. I don't get to touch technology as an architect, but, it's kind of fun to see it demoed here and there every once in a while, too. And so that's always great. Before I answer any questions, did you want to say anything, Leo?
Well, just for them to be prepared for the demonstrations.
Okay. So let me answer the one question that I think came up, and it came from Orlando Chemdry. Are a lot of companies able to pay high salaries for architects? So what I want you to think of is, there are some positions that generate money, and there are some positions that cost money. What if I told you that the average, and I'm not joking, the average of the top 10 stocks in the Dow 30, the average revenue is $287 billion a year. There's a reason I'm starting with them. So if you are able to make a 1% change in an organization's revenue, that's $3 billion, 1% change. So if you're able to create an AI recommendation engine that makes somebody dwell on a page that leaves them on there 1% longer and revenue goes up by 1%, you made a company $3 billion. If you ask for $800,000, it's nothing. And the reason it's nothing is because of the value you're actually generating. So it all depends on what problems you're able to solve. You go in there with MBA-like knowledge and you solve billions of dollars or millions of dollars of issues, then guess what? You're worth $500,000, $1 million a year or more. If all you know how to do is just configure technology, well, that's another story, because that's something where there are a lot of people can compete. So realistically speaking, that's why architecture is really an executive position. It's about learning the business, learning the pain points, learning the strategy, and then also being able to map that to a technology, a network technology, a data center, a compute, a storage, what have you. So I'll go through a lot of it, but that's why you see the average architect is about 200,000 for a role. And when you get to principal architect level, it's about 350 to 500, about 350, 375 on average. And that's why when you get into chief architect roles, it's not uncommon to earn 800,000 or more, because these are big business roles. So they're executive roles with tech, which means I need somebody that understands tech, not how to configure it, but how it works and how to put it together, which there's nobody out there, because everybody learns by doing versus learn by concept. So there's nobody out there. And now that person still needs to have big business skills, which puts you at the perfect end of the supply and demand curve. Every company wants one, and there's nobody out there that can do the job. That's why it's so easy to get hired as an architect when you're properly trained, and so hard if you're not. Hope that helps. Great question. And then I'll answer Aaron's question as well. And I'm going to do a lot more of it tomorrow. Aaron's question is, he has a little bit of experience working with APIs and SA360 is becoming an architect achievable. So Aaron, it has nothing what you used to do. I used to practice internal medicine. I was a principal architect within 2 years. Vladimir, for example, was a 20-year-old college student, a student of mine, first architect job, North Highland. Pierre was, I think he was 25. He was operating sailboats. First tech job, solutions architect at Leafs Web and Kana. Yvonne, 24-year-old waiter, first tech job as an architect, a solutions architect at AWS. Wallace Agana, for example, was a sales rep hired as a enterprise architect, straight as his first tech job at JP Morgan Chase. Whereas Al was a student of mine who was a sales rep whose first job was a senior solutions architect at Deloitte. Aaron, as long as you have the skills and as long as you get the training, you can get any job you want. Any job. But I can promise you what you learned as an engineer is not going to cover you to be an architect. And what I mean by that is you might need to know an API. But as an architect, I might need you to know if your weighted average cost of capital is 7%, how would you leverage that information to design a private cloud versus build a public cloud? As an architect, I might ask you, what's your IAM strategy for the organization? What are the architectural trade-offs you would face? I might ask you about the architectural trade-offs to go across going on a single cloud versus 3 clouds, for example. And that's the kind of answer I'm looking at. So the answer is yes, absolutely. You can definitely get there. I've taken nurses. Camille is a nurse. She's now the director of architecture. I've taken teachers like Nicole, whose first job was an architect. It doesn't matter your background. I've taken emergency medical technicians like Delroy Batten, got him his first job as a security solutions architect. Yes, you can. It's just about getting the right skills. I'll talk about exactly what those skills are on the webinar tomorrow. And I'm going to come in and do a career question and answer session tomorrow, because the questions came in and I want to help you. But yes, you can go do it, but you will need training. But that's the great news. You want to be an airplane pilot? You can do it. You want to go be a physician? I promise you can go to medical school and you could be a physician. You can do anything you want. I love that, because I practiced internal medicine for a little while and realized I love tech a little better. So I switched. 9 months later, I was a CCIA and I was working in networking. All right. So what we're going to do is we're going to play some of Leo's labs. Today's are going to be pretty basic. Tomorrow's are going to be fun. He got kind of geeky and I watched them and I was like, I really, really, really like this. So we're going to have some fun tomorrow. So let's play Leo's labs. Give me a hashtag Google Professional Cloud Architect. If you're having a good time, maybe give it a like. Maybe share this with someone else so you can share the wealth of the knowledge. That takes a lot to put one of these on, and we want to do whatever we can to help you build the best cloud architecture careers, enterprise architecture careers, solution architect careers. So let's have fun. I guess back to the Google Professional Cloud Architect exam content, Chris.
Hello. In this lab, I will demonstrate how to create a service account. But what are service accounts? When you need to authorize one service to do something in Google Cloud, you need a service account. A service account is just like a user account, but instead of allowing a user to execute tasks, it allows services to execute tasks. For example, a virtual machine may run as a service account. The account can be given permissions to access the resources the virtual machine needs. This way, the service account is the identity of the virtual machine, and the service account's permissions controls which resources the virtual machine can access. Here, I will use the search bar and enter Google Service Account. The first link is Service Account Overview from an IAM documentation. I will click this link to open the document. Here is the Service Account Overview document. We strongly recommend you read the documentation to learn about the services you are going to use. Here, the document shows different types of service accounts, service account permissions, service account lifecycle, several different aspects of the service accounts. Here, under the What Next session, there is a link to a document, find out how to create service accounts. But before opening this document, I will use the second link here, is to get best practices for working with service accounts. I will right-click this link to open the document in a new tab, and I will switch to that tab. Here are the best practices for using service accounts, and the document states, although service accounts are a useful tool, there are several ways in which a service account can be abused. And the document goes over privilege escalation, spoofing, non-repudiation, information disclosure. And to help secure service accounts, consider their dual nature. Because a service account is a principal, you must limit its privileges to reduce the potential harm that can be done by a compromised service account. On the other hand, the service account is also a resource. You must protect the resources from being compromised. This guide presents best practices for managing, using, and securing service accounts. Please read this document to learn how you can use and protect your service accounts. And it is important to mention that in these labs, I am not covering all aspects of the services I am describing or demonstrating. I am just demonstrating how you can start learning, start using the service, but you need to learn more about the service to cover all aspects. For instance, how the service is charged or the security aspects of the service, among other things. I will close this tab now and go back to the Service Accounts Overview page. And now I will click the link to find out how to create service accounts. The second paragraph states, by default, each project can have up to 100 service accounts that control access to your resources. You can request a quota increase if necessary. I will scroll down to the Create a Service Account section, and here are the steps. But before executing these steps to create the service account, I will scroll down to the What's Next session, and I will right-click the link to understand how to attach service accounts to resources. I will switch to that document. And as usual, please read the document, learn the aspects of the services you are using. Or even before you use the services, you should learn all aspects involved. Here from the What's Next session, there is a link to find out how to attach a service account to a compute engine instance. I will click this link to open this document. I will reserve this document for later use, and right now I will go back to the Create Services Account document and scroll back up to the steps needed to create the service account. I need to use the Google console and go to the Create Service Account page. So switching to the Google console, I will use the top left menu, and from the IAM and admin section, I can access the Service Accounts page. Here, I can click Create Service Account, give a name to the service account. I will call this HTTP Access Service Account. And I'll click Create and Continue. And I will click Done. So here is the HTTP Access Service Account. And this is how you can create a service account. In another lab, I will demonstrate how you can attach service accounts to virtual machines and how you can use service accounts to make your systems more secure. Thank you for watching. See you in the next lab.
Okay, Leo, that was great. Can you tell everybody what's in the next lab?
Yes, in the next lab, I will use that service account to demonstrate how it can be used. One aspect of using a service account is to limit the range of virtual machine or services that one task can be executed on. In this case, I created an HTTP service account to allow HTTP access to a certain number of virtual machines.
Fantastic. I look forward to this. Chris, let's roll with the next lab.
Hello. In this lab, I will demonstrate how to attach a service account to a virtual machine. To do this lab, I need one existing virtual machine and an existing service account. If needed, refer to previous lab to learn how to create them. In the previous lab, I demonstrated how to create a service account, and I opened this document and I reserved it. And now I will use the content of this document. I will scroll up and here is the What is a service account section. The document brings some points for you to keep in mind when using service accounts. You can attach the same service account to multiple virtual machines, but a single virtual machine can only have one service account attached to it. If you attach the same service account to multiple virtual machines, any subsequent changes you make to the service account affects all virtual machines that use that service account. And here, under How Compute Engine Uses Service Accounts, there are two types of service accounts: the user-managed service account and the service agent. A user-managed service account can be attached to a compute engine instance to provide credentials to applications running on the instance. These credentials are used by the application for authentication to Google Cloud APIs and authorization to access Google Cloud resources. The service agents are used by the instance to access internal process on your behalf. In addition, you can create firewall rules that allow or deny traffic to and from instances based on the service account that you associate with each instance. I will scroll down a little bit more to this section attaching a service account to an instance. And it says you can attach a service account to a compute engine instance when you create the instance or later. Only one service account can be attached to an instance at a time. If you attach a service account to an instance that already has a service account attached, the previous service account is no longer used by that instance. I will switch to the Google console now, and I will access the virtual machines instance page. And I will check the service account associated with each of the virtual machines I have right now. I will open the VM1, and the service account associated with the VM1 has the ID with some numbers -compute@developer.gserviceaccount.com. Let's check the service account attached to the VM number 2. And it is the same service account. And checking the VM3, it is the same service account. So this is the default service account created when the virtual machines are created in each project. The number will be probably different from project to project, but the remaining part, the compute@developer.gserviceaccount.com, will probably be common for all default service accounts created when the virtual machines are created. Going back to the service account document, I will click the link to change the attached service account. I will scroll down and remind you to read the documentation, learn about the services you are going to use. And here under the attach the service account and update the access scope, the first statement says to change a virtual machine service account and access scope, the virtual machine must be temporarily stopped. So I will go back to the console and stop the virtual machine number 3 because I want to update or to change the service account attached to this virtual machine. Going back to the document, it shows the steps needed to change the service account associated with the virtual machine. Let's go back to the console and hit refresh to check if the virtual machine is already stopped. And then with the virtual machine stopped, I'll click the name of the virtual machine to open its details page, and then I will click edit. Now I can scroll down to find the service account. And then I can change from the compute engine service account to the service account I created. Let me go back to that page to see the name of the service account I am going to use, and it starts with HTTP access service account. So I will select from here HTTP access service account. and I click Save to save the changes. Now I will verify that the service account was applied, and it's applied. I can click Start Resume to restart the virtual machine with this new service account attached to it. I will go back here to the virtual machine instances page. In this lab, I demonstrated how to attach a service account to an existing virtual machine. Another option to use service accounts with virtual machines is to select the service account when creating the virtual machine. This way, instead of the virtual machine being created with the default service account, you can select the service account in the creation process, so the virtual machine is already created with the correct service account. In the next lab, I will demonstrate how to create firewall rules to restrict HTTP traffic to specific virtual machines. Thank you for watching, and see you in the next lab.
Thank you for that, Leo, and thank you, everyone. Leo, could you talk briefly about some of the fun upcoming labs you have in the next couple of days?
Sure, Mike. The next content topics are about networking. And when we create, in this case, I already had 3 virtual machines created. And using the cloud providers console is very easy to create virtual machines, to create managed services. It doesn't require much work, but we need to understand the underlying technologies that allow to create those virtual machines, those databases, for instance, managed databases. And the next labs will show how to create this infrastructure, how to create a custom VPC, how to create custom subnets with specified IP address ranges, and then how to create the virtual machines, the instances inside those VPCs, and also using how to use load balancers inside those VPCs to direct traffic to different virtual machines.
Sounds fun. So I'll describe the technology, how the technology works, where it fits together, and then Leo's going to build it. We'll have some fun with that. And I love the way Leo demos technology. One day he demoed how to build a cloud to our students, and I saw that, and it was just so nice that I was like, Leo, we got to get you to do this. So, Leo, thank you for that. For everyone that's here, we hope you've enjoyed the Google Professional Cloud Architect Bootcamp we're doing to prepare you for the Google Professional Cloud Architect certification. This is day 2. You can still go back to see day 1. We've got 2 more weeks of this stuff. And I don't know, gives me a chance to get my geeky on, since I don't get to do that very often as a CEO, and I enjoy it. So I hope you're all having fun. If you've not given the video a like and you did learn something, maybe give it a like, maybe subscribe to our channel and hit the bell to be notified of new videos. Maybe share this with a friend. If you've got a friend that wants to learn something about Google, please share this, because we really want to help as many people as we can with this free Google Bootcamp. So please share that. As a reminder, I'm going to come on at 11 a.m. tomorrow. I'll be live and free. You can ask me any career question you want about any tech career. Want to know the impact of anything? We can talk about it. It's totally free. I'll be doing it at 11, and we'll be back tomorrow at 2 p.m. to go through this again. And on Thursday, I'm going to host a How to Become an Architect webinar. It'll be on Zoom. We'll go over the role. We'll talk about what we do. We'll talk about the skills that we have, and we'll make sure that you understand and you can ask any questions you want. Thank you for saying that we were clear. That was our goal, to kind of clarify some of the complexities and some of the mystery around computing and all the mysticism. So I hope we've done that. So it's been really great to see you. Hope to see you tomorrow twice, once in the question and answer session for the careers, once on the webinar, and then hope to see you on Thursday. So look forward to seeing you soon. So nice to spend the afternoon